So anyway, I think we should just try to start on this VJC paper. I don't know whether you guys have gotten to look at this VJC paper, but it is I remember what some of my VJC students were telling me last year, during my tuition class. Some of them were telling me about this paper, and they were saying that this is an okay paper, but that is only when you are experiencing the first half of this paper. So in the beginning of this paper, it felt okay, which is probably, which will be probably those kind of questions that we will be doing tonight. And the second half, oh no, goodness. Okay, I don't know whether you guys can hear, but the construction is like starting, they are starting to do this construction again. I'm so sad that there's this noise that's going to be going on throughout the live stream, but it is okay. Let's just focus on this VJC paper. But anyway, I was saying for this paper, the first half of it is actually pretty okay. And what some of my VJC students told me that their classmates experienced last year when they were doing this paper was that because it felt okay in the beginning, so they tend to allow themselves to slow down. And then after that, towards the second half, when they realize that the questions start to get either more difficult or start to get way more tedious, they find themselves in a rush to do questions that are actually of a higher level. And that is what I want to, a precaution that I want to give you guys. Just like the River Valley paper that we did last week, for those of you who did it together with me, you experienced the same thing, right? Tuesday we did the first half last week, and then Friday we did the second half, and I've gotten some feedback about the second half of the River Valley paper, that the standard sort of like just suddenly make this jump. It is going to be happening in this VJC paper, and I do believe that for a lot of you who are going to be taking your prelim this year, it is going to be the same for your school's paper. A-level, they have adopted almost the same format for the last few years. That means the first few questions will be okay, and the next few questions will be either more tedious or require you to analyze and think more. So my suggestion is, during the very first part, as much as possible, pace yourself so that you do not slow down. In fact, you should try to do a little bit faster in preparation for those harder questions that are in the second half of the paper. Okay, anyway, let's take a look at this VJC paper, VJC 2009 paper 1 together. So this is the VJC paper 1, and here is the MF26, which I hope some of you are already having this prepared in front of you. So let's take a look at question number 1. Okay, and in case some of you who are here who just joined us, I just want to tell you that in case you are hearing some drilling noise in the background, well, this is live stream, and now there's a construction going on outside my house. I'm in my house now, okay? So that noise that you are hearing, in case you are hearing it, at your computer, right? Okay, it is the construction noise, okay? So anyway, question number 1. Okay, it's an easy question. We are supposed to express this as a single fraction. So we have 12 over x plus 1 minus 7 minus x. And to re-express this as a single fraction, we are going to multiply the numerator and the denominator by x plus 1 divided by x plus 1. So we can combine them together. So x, so 12 and this term. And I think I'm going to just bring this negative inside. Okay, this is just your preference. For me, I don't really like to work with coefficient of x that are negative. So I'm going to bring this negative inside. So I have a plus, I have a x plus 7, then multiply by x plus 1, and this is going to be divided by x plus 1. So we have now a 12 plus this is going to be x squared plus this is going to be x squared plus x plus, oops, I've made a mistake. Okay, here is x minus 7. Okay, so it will be x squared plus x minus 7x minus 7. So this divided by x plus 1. And this is going to be equal to x squared. Then this minus 6x. Then this and this, it is going to be plus 5. And this is going to be divided by x plus 1. I know that this is going to be applied to this, so very likely we are going to be required to factorize this. So I'll either factorize it later or I'm going to do it now. So let me just do it now. this factorizing the numerator, we have a x minus 1 multiplied by x minus 5, and this is going to be divided by x plus 1. Okay, first part, 1 mark, done. Without using the calculator, we are supposed to solve this inequality, and very obviously to me that I'm going to bring this 7 minus x over to the left hand side so that I can have an expression that looks like this. So for the second part, we are supposed to go for 12 over x plus 1 is supposed to be less than or equal to 7 minus x. I'm going to bring this expression over to the left hand side, so 12 over x plus 1 minus 7 minus x. This is less than or equal to 0. Combining this into one single simplified fraction, which is this, and I'm going to re-express into the factorized form. So this will be x minus 1 multiplied by x minus 5 divided by x plus 1. This is less than or equal to 0. We have a very standard structure that we can follow to do inequalities that is like this. So we are factorizing everything into linear expression, and we want to make sure that the other side is equal to 0. Once we have gotten an expression that is like this and the other side is equal to 0, according to what we are taught in our schools, we can then sketch out a number line to represent all the roots of the individual factors, and those are going to be minus 1 from the denominator, then 1, and then 5. Substituting values into the entire expression, for example, substituting value like 6, a number that is bigger than 5, into this entire expression here, I'm going to get a positive. Then after that, substituting something that is between 1 to 5, for example 2, I'm going to get a negative number for this, and then subsequently it is going to be a plus, this is going to be a minus. We are looking for the region that is less than or equal to 0. So this is less than or equal to 0, so it's going to be this region, and it is going to be this region. So the set of values of x that satisfy this inequality here will be something that will be numbers that are less than minus 1. It has to be strictly less than minus 1. So strictly less than minus 1, because according to the expression that we are looking at here on the left hand side, x cannot be equal to minus 1, or else we will have a 0 in the denominator, and it will cause the entire expression to be undefined. So x is going to be strictly less than minus 1, but for the other set of values here, x is going to be bigger or equal to 1, less than or equal to 5. And I can see someone asking, how do you know that you are not supposed to do a long division? Can you see in someone is asking now, for an expression that is like this, how do you know that you're not supposed to do a long division? To me, it is pretty obvious that long division is not going to be applied here, because when we are trying to do a long division, that is when we are looking at an improper expression. So if we are looking at an improper expression, then that justifies for long division. An improper expression will look something that is like this. For example, if I have something like x squared plus 2x plus 1 divided by, for example, 3x plus 1. This is an improper expression because the degree of the numerator is 1 more than the degree of the denominator. In the numerator, it is a polynomial, so the degree represents the highest power, so power 2. The degree represents the highest power, power 1. So for this kind of scenario, if I want to manipulate this kind of expression, we will do a long division. But if I were to have something that is like this, 3x plus 1 divided by x squared plus 2x plus 1, I will not do a long division because this is already considered as a proper. So this is improper, yes, if you want to manipulate this long division. Another improper expression can look something that is like this. For example, this divided by 2x plus 1 divided by, let's say, 5 minus x squared. The numerator has a x squared, denominator has an x squared. So if you want to manipulate this, yes, long division. This kind, no. This kind, the proper kind, it is a bit like 3 over 5. You don't do a division to this to make it into a mixed number. But this kind or this kind, it is like a 5 over 3 or it is like a 5 over 5. Then it justifies a long division. But for this question over here, the question actually mentioned that you are supposed to re-express this thing. You are supposed to re-express this as a single simplified fraction. So when we are trying to do a long division, we are actually trying to separate a single fraction, for example like this, into two parts. But this question want it to be in one single part. So with all these hints that are given to us by the question and according to the expression that is given, we will not be doing a long division. So we will rather try to merge these together to form one single expression. Okay. Question number 1 is very simple, and I think it is in a good direction that schools are adopting, to try to set the first few questions as easier questions so it can get us more warm up. Okay, that's what A level is doing, and I think it's a very, very good way to set papers. So question number 1 done. I am hoping that tonight we can do all the way until maybe question number 7, and if it is possible, let's push for question number 8. Because the next session that we are going to be doing together, we are going to be looking at the second half of the VJC paper, and this second half is going to be like way more difficult. So I do suggest that since this period is a holiday, you can consider after our session today, since you have the VJC paper with you, if you don't have, probably you are watching us on YouTube, come over to Achevas TV, sign in, you will be able to get the VJC paper, work on that VJC paper first, then on the next stream, we can look at the next half of the paper together. Let's look at the next question. I think this is also a pretty okay question. Part 1, it is just a 1-mark question requiring us to do a differentiation to this. So dx, we are supposed to differentiate tangent inverse of x squared. So differentiating this, making use of our formula sheet, this is going to be 1 over 1 plus this thing square, so x squared, and applying chain rule, we have a 2x. So this is going to be equal to 2x over 1 plus x to the power of 4. Oh, and there were some people asking us about asking question here. I'm going to try to answer as many questions as possible, but I also want to try to finish this paper. So please continue to ask questions. Like last week, I had quite a lot of questions from you guys. And how to ask question, because on YouTube I cannot trigger that features that some of you saw just now, where I can look at the question, review the question, point out which question I'm answering. So this feature is on the Achevas TV. So if you are planning to ask some question, I'm not monitoring YouTube right now. So if you are planning to ask question, you can again hop over to Achevas TV, sign in, and there will be this platform, where you can ask me some questions from there. Okay. So we have this as the first part. We are supposed, let me write this down here. So this is going to be equal to 2x over 1 plus x to the power of 4. Let's move on to part 2. Part 2, hence or otherwise, we are supposed to do an integration for this. I guess it is pretty obvious for those of you who have been practicing your integration technique. This is a question that is asking us to integrate by making use of integration by parts, right? So integration by parts, let me write down the question first. We are supposed to integrate from 0 to 1 of x tangent inverse of x squared dx. So I'm going to try to apply integration by parts. One of it is going to be u. The other one is going to be dv dx. So getting my hint from part 1, since we can differentiate this and we definitely cannot integrate tangent inverse directly. So I'm going to let u be equal to tangent inverse of x squared. And dv dx, this is going to be equal to x. From here, I want to find out what is du dx. And this, we have already done it in the first part. And that is 2x over 1 plus x to the power of 4. And as for this, v is going to be equal to x to the power of 2 divided by 2. So from here, this, I can rewrite it as uv. So it is going to be x squared over 2, then multiply by tangent inverse of x squared uv. And let's not forget that this is a definite integral, so we are going to be integrating from 0 to 1, minus integration of from 0 to 1 v du dx. So this multiply by this. Half and 2 will be cancelled, then x squared and x, I will get a x to the power of 3 divided by 1 plus x to the power of 4. dx. Again, I would say that this is a simple integration because what we are going to be making use of for this is fx f prime x. If we were to be letting fx be the denominator, 1 plus x to the power of 4, then f prime x is going to be equal to 4x to the power of 3. We have an x to the power of 3, we are just lacking a 4, and it is very easy for us to generate a constant for this. Okay, so the next line that I'm going to be writing, let's evaluate this in the next line. So if I were to substitute 1 in, we have a 1 square over 2, that is half. If we were to substitute 1 in, we have a tangent inverse of 1, and that is pi over 4. Then minus away, substituting 0 in, it is obviously going to be 0. So we have this after we substituted the numbers. Then minus this, like what we have planned, we need a 4x to the power of 3 instead of just x to the power of 3. So we are going to generate a constant, so 1/4, so that I can rewrite the expression inside as 4x to the power of 3. This is my f prime x. And fx is going to be 1 plus x to the power of 4 dx. This is pi over 8 minus 1/4. Integrating this now, since we already have the fx f prime x form, and getting inspired by the integration of 1 over x. Integrating 1 over x is ln modulus of x. So this should be ln modulus of 1 plus x to the power of 4. And I've been telling my tuition class that since this year we are heading for the A-levels, A-levels has a habit of re-expressing any expression or any numbers which is already positive all the time. If there were to be this modulus, they will remove the modulus and replace it by a curved bracket. There is nothing wrong if I want to leave the modulus, because it is okay to write it as modulus of 3, a positive 3. Okay, but Cambridge will write this as just a curved bracket if they recognize the expression that is inside or the number is inside is always positive. So for those of you who are doing A-levels this year, I think it is a good thing to do, okay, to try to adopt this style of writing so that we can synchronize to what Cambridge is doing this year, most likely. So we will write this as this, x to the power of 4. So it is going to be this, integrating from 0 to 1. So we have this, and this will be pi over 8 minus 1/4. Substituting this in, we have a ln 2. Minus substituting this, we have a ln 1, and ln 1 is 0. So this is pi over 8 minus 1/4 of ln 2. Okay, so I guess Sudasan okay, I guess Sudasan, who is here asking this question, who later on, Sudasan, I assume you are the same person saying that it is okay. It is like what I was just mentioning. Since the expression 1 plus x to the power of 4 is always positive, it doesn't really matter whether you're going to put a modulus or not. Okay, and since Cambridge go for curved bracket instead of modulus when the expression is always positive, I'm going to just replace it by a curved bracket. Okay, so this is also an easy question. And for those of you who have just joined us, I was saying just now that for most of our prelim papers this year, and Cambridge will very likely be adopting the same style, is that the first few questions are usually going to be pretty okay. What some students tend to do is, because they saw the first few questions as okay, they get a little bit more relaxed, which is good. Okay, that is the main purpose of why the first few questions are easier. But let's still try to do the questions with a bit of urgency, because for this VJC paper, like the feedback that I get from some of my students, some of my VJC students last year, and they were telling me that their schoolmates are facing the same problem, was because the first few questions were easy, it actually made them got too relaxed. They were a little bit too slow, you know. So when they got to the second part of this paper, they realized they were really rushing and sweating. Okay, if you were to do the second part yourself tonight, you will understand what I'm trying to say. But today we will be just doing the first part of this VJC paper, and we will be setting aside another time to do the second part of this VJC paper, probably this week. Next, let's look at question number 3. Question number 3, 2 marks for us to do the differentiation. Oh, somebody was commenting about my hair, and you know, yes, I've just gotten a haircut, but I also realized at the same time, I'm not sure why, but I have positioned myself just at a perfect place where the smiley face is covering my hair. So it's like very weird. Every time when I trigger the function to look at your question, then I have this thing covering my hair. So, well, I don't think I can change. Maybe the next time I'll change the place that I'm going to position myself. But I thought this position is pretty okay. You know, bottom left. Then when I'm talking about whatever that is on the screen, then I can just point. It's easy. But anyway, VJC paper, Prelim 2019, paper 1. We are supposed to differentiate this 3x squared 2 to the power of x. We will be applying the product rule. So I'm going to let 3x squared be the same. We are going to differentiate 2 to the power of x. Differentiating 2 to the power of x is 2 to the power of x ln 2. Then plus, I am going to differentiate this 3x squared, which is 6x, then 2 to the power of x. And for this 2 to the power of x, I do realize that some of us may not be the most comfortable in differentiating 2 to the power of x. For me, I have already memorized the formula for 2 to the power of x. So I am differentiating this as if I am differentiating e to the power of x. Differentiating e to the power of x is e to the power of x. The way that we conduct our differentiation at H2 math level is actually very similar to our secondary school. We differentiate by using standard results. I know some of you have been exposed to differentiation by using the first principle, but that is not tested in H2 math. So I am differentiating using standard results. But just in case some of you didn't actually memorize this 2 to the power of x as a standard result, then what I would suggest that you can think of doing, it is okay, because it is very easy to differentiate this if you were to apply implicit differentiation. So I know, for example, let's say I didn't manage to memorize the standard result that can help me to differentiate 2 to the power of x, and I need to differentiate 2 to the power of x. What we can try to do is to let y be 2 to the power of x. And I'm going to do an implicit differentiation. I will do ln on both sides first to manipulate this. So I have a x ln 2. Then differentiating the left hand side, it is 1 over y. Then dy dx. Differentiating the right hand side, ln 2 is a constant and x is just x. So I have a ln 2, which means that dy dx, this is equal to y ln 2. And what is y? Y is 2 to the power of x. So we have a 2 to the power of x ln 2. So we do have a backup just in case in the exam you see something that is not that familiar to you. You can think about letting y be equal to that expression, and maybe through implicit differentiation you can find a way to make use of standard results to continue with your differentiation. So I have this, and let me try to simplify this by a little bit. If I were to simplify this, I am going to factorize out 3x 2 to the power of x, which will then leave me with an x ln 2 plus 2. Okay. So I have this, and I am going to make use of this to do part 2. So let me write down my result here. So this is 3x 2 to the power of x, then x ln 2 plus 2. Then part 2 of this question. Okay. Okay, I'm not sure whether you know, this question that is asked is I'm not sure whether you are a Singapore student, okay, because in the Singapore syllabus, in H2 math syllabus, we are not actually required to do we are not actually required to initiate a substitution. Okay, this question is targeted on question number 2. Okay, when we were trying to do an integration. So this is integrating question number 2 using substitution. And because in our syllabus we don't initiate it substitution should always be triggered by the question. So what this person has suggested is correct. It's just that it is not really so relevant to our syllabus. So but of course, for those of you who are not doing the H2 math syllabus in Singapore, you can go ahead and try this substitution. It should work. Okay, part 2, where I'm glad some of you are actually helping me to answer question. So this is a 1.5 hour session, and I'm hoping to stick to the 1.5 hours, or maybe overshoot by that little bit, but let's see how. Okay, so part 2, I've already now gotten this. We are supposed to find the equation of the tangent for this when x is equal to 1. Okay, I think this is a pretty okay and easy question. So when x is equal to 1, I want to try to find the equation of the tangent. So in order for me to form the equation of the tangent, I need the x coordinate of a point and I need the y coordinate of the same point. So when x is equal to 1, goodness, okay, I'm so sorry, I have to laugh because I thought that the construction has stopped. But right outside my house now, in case you guys can hear, and just now I was trying to do that little bit of complaining, is that they are suddenly drilling and now they are starting again. So anyway, I'm not going to let that distract me. Okay, so when x is equal to 1, I'm going to find the corresponding y value. So y is going to be 3 times of 1 square, 2 to the power of 1. So y is going to be equal to 6. And I'm going to find out what is dy dx. So dy dx here is going to be 3 times of 1, then 2 to the power of 1, 1 time of ln 2 plus 2. So we have a 6 of ln 2 plus 2. This will be sufficient for me to find the equation of the tangent. That will be y minus the y coordinate 6 is equal to the gradient. Gradient is 6 ln 2 plus 2 of x minus the x coordinate, which is 1. I mean, I feel that it is okay leaving it in this form, but for us Singaporeans, I think it is very common for us to re-express our equation of tangent in the form of y is equal to mx plus c. So maybe let me just do that. So y is going to be equal to 6 times of ln 2 plus 2 times x. Then minus away this. If I have to multiply in, we have minus 1 times this, so minus 6 ln 2 minus 12. And this 6, I'm going to bring it over to the other side, so plus 6. So y is equal to 6 ln 2 plus 2 x minus 6 ln 2 minus 6. Okay? In fact, right, I'm not sure about this, but somehow they are still doing some drilling. I think we should be appreciative. At least I am not the one drilling, and it is pretty hard work. Okay, I can see what they are doing from outside. I mean, outside my window. So it's okay. A little bit of construction is fine. Goodness, I'm not sure who find this like a gentle breeze. To me, it's definitely not a gentle breeze. It is almost like a T-Rex outside my house. Okay, let me move on to the next question. Question number 3 is still, question number 3 is a gentle breeze, I find. Question number 1, 2, 3, it makes us feel so relaxed, and because the questions are just not that difficult. But I do think that for a VJC student doing this paper last year, when they reach something that is like maybe question number 8 or question number 9, wow, goodness, I think you should really try to be very, very, they should probably be sweating a lot. So next, question number 4. question number 4, this question here. Okay, let's take a look at this question number 4. Okay, question number 4, we are supposed to do a transformation. And I think question number 4 is an okay-ish question too. Let's take a look at this question together. Oh, actually question number 4 is not as okay, because question number 4 involves a feature that I've been warning my tuition class. In fact, we spend time to analyze this feature because this feature is many times missed out in our lectures, which is actually oblique asymptotes. Okay, so let's see whether this oblique asymptote is going to cause any little bit of confusion in case some of you find yourself not exactly knowing how to analyze this oblique asymptote for the transformations that we're going to be doing next. I do encourage you to spend some time to do that analysis, because a lot of your schools will be setting oblique asymptotes questions during your prelim. Okay, I've just seen one oblique asymptote appearing in SAJC's test. Okay, I don't know whether they are doing the same test for the entire school, but I'm starting to see this happening, oblique asymptote being set in a question that require transformation. So part 1, let's try. Part 1, okay, we are supposed to draw the graph of y is equal to f modulus of x. I think this is easy to draw the graph of y is equal to f modulus of x. We are going to be keeping the right hand side here. Okay, and we are going to just ignore the left hand side. Okay, so that's what we are going to be doing. So, and according to what I've mentioned last week, I think there's a very good habit that we can be adopting when we are trying to do the graph. I mean, when we are trying to sketch graph, which is as much as possible, let's aim to sketch all the asymptotes first before we sketch in the rest of the parts of the graph. So I'm going to do the same thing now. Let me try to sketch in all the possible asymptotes as much as I can first. So let me sketch in a horizontal asymptote. Yay, I think the construction is stopping. I seriously think that they are stopping. So I have a y-axis, I have an x-axis. The vertical asymptote will remain the same. So all the way, this is my vertical asymptote, x is equal to 4. We have an oblique asymptote. So from here, all the way to, let's say here, this is y is equal to 10 minus x. I think it is actually a good idea to just sketch the left hand side's asymptotes first before we do the reflection, but I think I will probably just sketch this part first. Then as I reflect, we will try to sketch in the asymptotes at the same time. So let me do that also. I can see that this portion here, it is stopping at this point. So I'm going to also try to sketch it in the same way, this. And I do want to try to make sure that my graph tends towards the asymptote, because something that is like this, I do believe that for a lot of your schools, you're going to just get marks minus off. So please don't do this, okay? Although the question happened to accidentally have this, but this is a vertical asymptote, the graph should tend towards the vertical asymptote. And there's one very common mistake that I see students make, like all the time. It is a mistake that I find is very painful to commit during the exam, which is for a point that is like this. When you are trying to do a reflection, I see a lot of students, they will try to draw the other part together with this part as something that is like this. You're trying to make this point here into a nice minimum curve, minimum point where the curve is in this manner. This is incorrect, because if you were to look at this question here, in this question here, if you were to draw a tangent, this tangent is at an angle, which means that if I were to be reflecting this about the y-axis, the tangent will also be at an angle, which means that the curve should be curving this way. And that is why this portion here is not going to be a nice smooth curve. This portion here is going to be a sharp point. So I want to make sure that this sharp point exists as I try to do the transformation. So if I were to draw the other part of the asymptote, I have a vertical asymptote here. So this is x is equal to minus 4. I want to make sure that this is a sharp point. So here, and going all the way up, this. Okay, and I'm going to be drawing this part here. So this is okay. So I have my graph, and I'll try to make sure that my graph tends towards the asymptote. It will be touching the x-axis here, then going all the way, tending towards the oblique asymptote. And this point that is here is 6, 0. And we will be reflecting this across reflecting this about the y-axis, which means we need to be sketching now the oblique asymptote. So for my oblique asymptote, it is going to come down here, and it's going to pass through this point. So from here, passing through this, and then all the way. And you know what is the problem? The problem is the labeling of this oblique asymptote. For those of my students who are doing this question together with me right now, you remember we were talking about the labeling of an oblique asymptote through a translation scaling reflection question. The problem is not about the sketch, because it is just simply this, and we are going to be reflecting this about the y-axis, and this is okay. The problem is the labeling of the oblique asymptote as it goes through translation scaling reflection, the labeling. So how are we going to be labeling this? I don't think this is that difficult. But what if it were to be appearing in another question which require horizontal transformation, horizontal scaling or horizontal translation? Then it may actually be even more of a challenge to try to label the oblique asymptote. In general, I need to know what is the transformation that has taken place. For a reflection about the y-axis, it is going for this transformation. From this, it will be transformed to this, with a reflection about the y-axis. So all the x is going to be replaced by minus x, and that is what I'm going to try to do for the oblique asymptote in terms of labeling. It is supposed to be 10 minus x, and what I'm going to do is I'm going to replace the x by minus x, because from this transformation to this transformation, a transformation that is going to be a reflection about the y-axis, it is when we try to replace all the x by minus x, and that is what I'm going to impose to the oblique asymptote. So the labeling of this is y is equal to 10 plus x. And now I can sketch the graph. So we have this part of the graph touching. Oops, I missed it. So touching, then going all the way down. Okay, and this point here will be minus 6 and 0. So this is my graph of y is equal to f modulus of x. Next, let's sketch the graph of y is equal to 1 over fx. Okay, I can see some VJC students here. Hang on, let me take a look at the questions. Okay, yes, VJC student. Okay, next, 1 over fx. Let's try this question together, 1 over fx. And let's see whether this oblique asymptote is going to pose for us another challenge. So again, for those of you who didn't recognize the problem with oblique asymptote, I don't think this is going to be a question that can help us to solve all oblique asymptote question. So my encouragement to you is, after our session, do try to spend some time to think about how you are going to be handling oblique asymptote if you're to be appearing in a transformation question. So let's sketch the graph of y is equal to 1 over fx. Okay, let me just plant my graph here. Okay, let me put down my xy axis. Okay, this my xy axis. Okay, I can see there are VJC supporters here also. So anyway, okay, this we are going to try to, for the graph of y is equal to 1 over fx. If you were to take a look at the theory outline on the Achevas TV, I have a suggestion of some steps that you can take in order for you to sketch the graph. The steps that I try to work out on the Achevas TV are actually steps that helps us to bring out the key features first. For example, asymptotes. So the first thing that I tried to mention on the Achevas TV was to focus on doing all the transformations for the asymptotes. Then the second thing was to try to focus on the xy intercept. Then after that, we will do an analysis of the graph from the left to the right. So I'm going to follow those steps on the Achevas TV. First thing, I'm going to work on all the asymptotes as much as possible. So we have a horizontal asymptote here, and this horizontal asymptote will become a new horizontal asymptote. and this is going to be a horizontal asymptote of y is equal to 1 over 6. We have a vertical asymptote here. Vertical asymptote will become an x-intercept. So we have a point here, let's say, and this point here is at 4, 0. So I've worked on the asymptotes. Next, I'm going to work on, there's still an oblique asymptote. How do we do the transformation for this oblique asymptote? So let's say we have never really studied properly, what kind of features this oblique asymptote is going to become. So let me postpone my analysis of this first. Okay, so I've worked on the horizontal asymptote and I've worked on the vertical asymptote. I've tried to work on all the asymptotes as much as possible, and probably not the oblique asymptote yet, so I'm going to delay it to my step 3, which is the analysis portion. I'll talk about it in a little while. So step 2, I'm going to try to work on all the xy intercept. So I have this intercept here, which is at 0, 6, and this will become a point 0 and 1 over 6. And we have an x-intercept here, 6, 0. An x-intercept will become a vertical asymptote. So I will have a vertical asymptote all the way. So this is going to be my vertical asymptote, x is equal to 6. Oops, I have my x-axis and I have my y-axis. We are trying to sketch the graph of y is equal to 1 over fx. This graph, or this labeling of the graph that I'm going to be drawing, simply tells me exactly how I'm going to do my third step, which is the analysis. I'm trying to work on all the y, I'm trying to sketch a graph where the y coordinates that is on this graph represents 1 over fx, where fx is the y coordinate that is on this graph. So basically we are just trying to take the y coordinate on this graph, which is a representation of fx, for example 6. When it's transformed to this graph, this point is going to be transformed to 0 and 1 over 6, because it is going to be 1 over the original y coordinate, which gives us this point. This forms for us the basis for all analysis in our step 3. Let's say we are looking at a point that is here, and I'm not very sure what this point is going to become when it comes to here. We can always assign an arbitrary coordinate to this point. So for example, an arbitrary coordinate for this point, I know it is going to be very, very much to the left. So let's say this is going to be like 1000, and it is a little bit less than 6 in terms of the y coordinates. So I'm going to write this as, for example, 5.9, which means that this point is going to be transformed to minus 1000 and 1 over 5.9. And 1 over 5.9 is a number that is bigger than 1 over 6. So I know that point is going to be transformed to a point that is slightly above 1 over 6. Then it will go to this point. This point minus 3, 5. Minus 3, 5 is going to go to a point minus 3 and 1 over 5. So it will go to this point here. Let's say it is here. So minus 3 and 1 over 5. Which means that from here, as a horizontal asymptote, it will go to this point here. And I know the next point that it's going to go to is going to be 0, 6, which is 0, 1 minus 6. So from here, you go all the way down to here. So far it is still okay. Then after that, it is going to move closer and closer to x is equal to 4. And we know when x is equal to 4, y is going to be equal to 0 for my graph of y is equal to 1 over fx. So I'm going to connect this here. And let's say now we face a problem, because as we start to go from x is equal to 4 to x is equal to 6, I'm not very sure whether my graph is going to go up or whether my graph is going to go down when it goes to x is equal to 6. I'm going to just plant a point that is just before x is equal to 6. So let's say the coordinate of this point is 5.9, and the y coordinate, I'm going to assign to it an arbitrary value also. Let's say negative 0.01, for example, which means that this point will become 5.9 on this graph. It will become 5.9, and 1 over negative 0.01, it is negative 100. Which means that a point that is roughly here will become a point that is minus 5.9 and minus 100. So it will be like way below here. That is how I can justify that my graph is going to tend all the way to here instead of going up. But this is actually a very, very easy graph to draw. I've already done this with my tuition class a lot of times, and I'm hoping that we, for us doing this kind of question through our tuition, we are really drawing this kind of graph like very fast and very accurately, because that can be practiced, and we should definitely aim to do that. So for example, a point that is here, I'm trying to analyze. Should I start from here or should I start from here when x is bigger than 6? So I'm going to assign to this an arbitrary coordinate. So for example, 6.1. The y coordinate I can see is probably, somewhere that is around negative 0.01, for example. And this point, once it goes through this transformation, it will be 6.1 and negative 100 also. So it will be like 6.1 and negative 100. So it's going to be somewhere here. So I'm going to go from here and you will start to go up. And this is where the problem comes here. When it comes to this point that is here, which is a feature that I didn't analyze just now when I was trying to work on all the asymptotes. So once again, I'm going to just plan for myself a point. So for this point here, let's try to analyze, okay, what will this point become? So I'm going to assign to it an arbitrary coordinate. Let's say, since it's very, very positive in terms of x, so I'm going to go for, let's say, 1000. And as for the y coordinate, it is actually pretty negative also. So let's say negative 1000 or negative 100. So this is going to become a point 1000 and negative 0.001. So so 1000 and negative 0.001 is probably going to be a point that is here, like 1000 and negative 0.001. So I'm going to be connecting this point here. Okay, I will be connecting this point here. And as we connect the point from here to here, I believe that there are three possible options. There are three possible options. One is, if this is the x-axis, should I try to connect it this way and it touches the x-axis? No, it shouldn't just touch the x-axis because the graph is going to continue. So it cannot just suddenly stop at the x-axis, so this is out. Or can I draw my graph in such a way that it just stops before the x-axis and not touching the x-axis? No, it cannot be just stopping before the x-axis. When we are drawing a graph of, for example, a parabola, when we draw a parabola this way, it doesn't mean that the graph stops here, right? The graph is actually going to continue. It's going to continue, which means that if you were to just suddenly, don't draw anything after this point, it is supposed to represent that it's going to just continue and continue. So this is also not correct, which leaves me with one last option. One last option is, since x is going to continue, since y will also become more and more negative, that means my graph will just go closer and closer to 0 from the negative direction, but never ends. This is synchronized to the feature of a horizontal asymptote, which means that this point, although it is here, but if I were to just keep drawing the rest of the points that is continuing from here, I'll be getting points that are very close to the x-axis, and this justifies for me that from here, we will be getting a horizontal asymptote. So we have a horizontal asymptote of y is equal to 0. This is the problem. This is one potential problem of an oblique asymptote when we are trying to sketch it for the graph of y is equal to 1 over fx. Yep. For whoever wrote this, I am suspecting, okay, that you are one of my students, right? Because in our tuition class, we talk about the power of using endpoints. Okay, I don't have time to talk about it here, but the power of endpoints can really help us to do a lot of questions. So for you, if you are my student, okay, I'm very happy that you remember this, okay? Using endpoints to analyze the three possibilities, it will be way clearer than what I'm trying to sketch here. But what I'm trying to just sketch here about the three possibilities should roughly still work as well. Somebody is asking here, well, I'm really have to get used to the fact that this question thing that is popping up is somehow like so near to my head. So anyway, will Cambridge penalize when we have a -3 that is closer to that is further from the origin than x is equal to 4? I don't think Cambridge will penalize unless it is very extreme. Like -3 is like so far away, and then 4 is like so close to the origin. Then as a sketch wise, it just feels very weird, because although a sketch doesn't need to be super accurate, but the relative positions of the points should actually still be correct. So as long as it is not too extreme, I don't think Cambridge is going to penalize. Okay, we are at question number 4, and let's continue with question number 5. I want to see whether it is actually possible for us to do all the way until question number 8 today, but I'm going to just aim for question number 7 first. Let's do 3 more questions. Question number 5. Yeah, I was actually thinking of trying to seat myself. Somebody was suggesting sitting myself at the bottom right. I was also thinking of sitting myself at the bottom right. Let's see how okay. I remember I was trying out at the bottom right once, and some other stuff, some other overlays sort of like blocked me when I was on some other social platform. I can't remember which one. So it blocked me like right on my face. So I was very disturbed by that. So I shifted myself to the left hand side. But now my own overlay of question is like covering my face. Okay, anyway, let's look at this question number 5. Okay, question number 5, we are referring to the origin O and have a point P, and point P has a position vector of 3a, so I know OP here is equal to 3a, and position vector of Q is a plus b, so OQ here is a plus b, and we have a point M, and point M is a point that is on QP extended. I'm not sure whether you guys have any problem with reading this QP extended, because I do realize a lot of students, they have taken this phrase QP extended for granted, and it is only during the exam then some students start to question, if I have Q here, if I have P here, then QP extended, does it mean that M is here or M is here? This is something that I will suggest that you memorize as a mathematical phrase that is specific to our H2 math syllabus. So when a question suggests that it is QP extended, then what it is trying to convey is going to be from point Q, then after that to point P, QP extended. So I'm going to get a point M here. Okay, so this statement here, my suggestion is to be memorized. Okay, there is a reason why I really can't remember why I shifted myself from bottom right to bottom left. Okay, but I think bottom left is also okay. It's just that now I'm trying to answer a question like this. Then yeah, it's pretty cute. You know what if I were to move my head up a little bit? Oh, okay. Anyway, let's continue with this QP extended, and according to the question, PM is to QM. This has a ratio of 2:3. So PM has a ratio of 2 and QM is a ratio of 3. That means this must have a proportion of 1:2. In order for me to find M, the position vector of M, I'm going to do a ratio theorem with P in the center. I'm going to reference all this to the origin O. So I have this vector here, and I have this vector here. What I'm supposed to find is this, but when I try to apply the ratio theorem to part 1, I'm looking at QP, the center vector, and this is going to be equal to 2 times of OQ plus 1 time of OM. And this is going to be divided by 2 plus 1. My aim is to find OM, so 3, 2 plus 1, 3. I multiply across to the other side, 3OP. This is equal to 2OQ plus OM. And this should help us to find OM. OM is going to be 3OP minus 2OQ. Oops. 2OQ. So it's 3 times of 3A minus 2 times of A plus B. So we have a 9 minus 2, this is going to be equal to 7. So we have a 7A minus away 2B. Okay, I guess a VJC student is asking about why 1:2, because the question says PM is 2 proportion, QM here, QM is 3 proportion. So if this is 2 proportion, if this is 3 proportion, so here must be a 1 in terms of proportion, where that is why 1:2. So now I have OM. So OM here is 7A minus 2 B. Okay, next, let's look at part 2. Part 2, we want to find PQ cross OM. OM we already have, but we do not have PQ yet. So let me find PQ. PQ is OQ minus OP. So OQ, A plus B, minus away OP, 3A. So this is going to give me a minus 2A plus B. Still pretty easy, I would say. So now we will look at PQ cross OM. PQ cross OM. Okay, we'll look at this. So PQ, this is going to be minus 2A plus B. So I have this cross OM is 7A minus 2B. Okay, so I have this cross this, it is minus 14 of A cross A. And this, it will be plus 4 of A cross B. This, it is plus 7 of B cross A. This and this, minus 2 of B cross B. But again, we have to know that A cross A is a 0 vector. B cross B is also going to be a 0 vector, which means that we are going to be left with a 4A cross B plus 7B cross A. And A cross B is the same as minus B cross A. So I'm going to rewrite this as A cross B plus 7. This is the same as minus A cross B. So my final answer here is going to be equal to minus 7 plus 4. This is minus 3. Minus 3 of A cross B. Okay, this is part 2. And part 3, 1 mark. State the geometrical meaning of PQ cross OM divided by modulus of PQ cross OM, modulus of this divided by modulus of PQ. When it comes to geometrical meaning of, this is a very common kind of question that we will be facing in the exam. My suggestion is to be able to do this efficiently in the exam. Of course, we have to customize it according to what the question is asking, but one very efficient way that I realize is actually to do this purely by memorization. That means along the way, from now all the way until your prelim, from now all the way until your A-levels, you will definitely be seeing quite a few kinds of questions that ask you for the geometrical meaning. My suggestion is, even if you don't know how to answer it when you're looking at it, then try to put it down in a list for yourself so that you can revisit it to either trigger some to bring out some of the things to bring out if you were to be this case the definition, then you plant it into your as you are doing questions instead of coming out with the meaning during the exam, because the marks is not going to be a lot. And if you are trying to process this during the exam, it may not justify the working. So for this, if I were to just base on memorization, okay, this is going to be the shortest possible distance from O to the line PQ. So let me just very quickly write down here first. So the meaning of this is the shortest distance from the origin to the line that passes through P and Q. But let me very quickly show you why this is so. If you have had memorized the formula for cross product to represent distances, so this will actually give you a bit of hint of why the answer is this. Like what I was telling you, it is actually more efficient, I find. Although it is not the best possible way for us to be learning vectors, but it is actually more efficient to be answering this kind of question through something that you have memorized before the exam starts. But if I were to do a bit of analysis to this, it is actually pretty possible to show why this is the shortest possible distance. Let me show you, according to the diagram that we have just now, right? We saw that it is going to be like something that is like Q, let's say P, and let's say M is here. So we are looking at this PQ cross. So we have this. So we have a PQ and we want to cross OM divided by modulus of PQ. So we have a vector PQ that I can visualize here. We do not have OM here, so I'm going to just draw OM. So something that is like this. So we have OM, okay? And if I were to just work out the cross product formula for this, the numerator can be re-expressed as modulus of PQ, modulus of OM, sine theta. And theta is going to be the angle that is between the two vectors that are involved. So PQ and OM. So I'm going to take it as this vector. Let's say theta is here. So it is this divided by modulus of PQ. So what you realize is that this PQ and PQ can be cancelled. And I'm going to be left with modulus of OM sine theta, right? And if you were to come back to here and find modulus of OM sine theta, you'll realize that it is here. If I were to draw a vertical line down and 90 degrees, this is the distance modulus of OM. And if I were to apply the right-angled triangle for sine is opposite over the hypotenuse, which means that this length here is going to be modulus of OM sine theta. Well, that is why this, which is in the end reduced to modulus of OM sine theta, is the shortest possible distance from the origin to the line that passes through PQ. But going through this process, it just cannot justify the marks, this 1 mark. That is why my suggestion is, in the exam, for the sake of our exam, in our preparation for it, this is better to be memorized and then customized for the question instead of deriving it from scratch. This is question number 5. Okay, hang on, let me take a look at the questions that you guys are asking. Somebody is saying that the YouTube comment section is very chaotic. Actually, I've never looked at my YouTube so far, because every time when I'm like doing my math here, right, I have been looking at the platform on Achevas TV. So once again, if the YouTube platform becomes too chaotic, I will encourage you guys to come over to Achevas TV, because at least from here, it is easier for me to manage. But please don't bombard me with all the questions, okay? So it's easier for me to manage, and I can see your question and I can try to answer your question according to this little overlay here. Hang on, let me see. Is there any question that I want to try to reply? I'm so sorry, okay, I may not be able to answer all your question. Really? The YouTube is filled with VJC people. Last week we did Real Valley. So are there any Real Valley people here? Why didn't you fill the YouTube comments with Real Valley comments? By the way, you know this magic triangle? Somebody is asking what magic triangle. I mentioned this on Achevas TV also under the theory outline. The magic triangle is something that I've been using together with my tuition class. It is a triangle that we use to derive every single distance related question in vectors. It is just a simple right-angled triangle, but it is very, very useful in derivation. Next time if there were to be a chance, maybe I can just show it here, okay, but I'm going to do more questions today, so I'll skip this magic triangle. It is a triangle, but because it can help us to solve all distances question in vectors, that is why together with my tuition class students, we call it the magic triangle. By the way, I've grown to learn, I've grown to love economics too. So yes. Okay, let me look at the next question. Question number 6. Okay, this question. Question number 6. Question number 6 is we have a function here. Okay, sorry, I was just looking at some of the comments and the questions that you guys have asked. Hang on. Let me remove some first so that it's easier for me to trace. I'm so sorry, okay, if I didn't manage to answer all your questions. I am okay. Okay, I'm going to just archive all your questions first, okay? I'm going to move on to I'm going to move on to question number 6. So for question number 6, part 1. Question number 6, part 1, we are going to look at this algebraically. So the aim of this word algebraically is so that we are not going to be using graph. Okay, so in a way, the motivation of this question is for us to find the range of f without trying to sketch the graph. But if you were to try to understand the way that range of a function works, it is the output of the function. So on a graph, although we didn't actually sketch the graph, but I'm going to just visualize how range is being obtained from a graph in general for the function fx. So from the graph, the y coordinates are going to give us the range of a function. And if we are supposed to algebraically find all the possible y coordinates, we have a very good strategy. A strategy that is to make use of a horizontal line. So I'm going to create for myself a horizontal line. I'm going to call this horizontal line y is equal to k. My purpose is this. My purpose is to have a horizontal line, and I want to make sure that this horizontal line will cut the graph. It's not exactly the graph of, because we are not supposed to be sketching the graph of this to do this question. But I know in general, as long as a horizontal line were to be intersecting the graph, that means that horizontal line should generate a y coordinate that belongs to the function, that belongs to the range of the function, correct? So we're going to make use of this. This is my t, where I'm going to generate a horizontal line. I'm going to let a horizontal line be y is equal to k. And I'm going to call this equation number 1. As for what the question has given me, I'm going to let y to be equal to this 12 minus 3x divided by x squared plus 4x minus 5. And I'm going to call this equation number 2. What I plan to do is to solve this as a pair of simultaneous equation, because my plan is to let this horizontal line be cutting the graph. Whatever it is, I'm not sketching the graph, but I'm letting this horizontal line be cutting the graph. So I'm going to find the intersection. So as in, like, I'm going to not find the intersection. I'm going to try to work as if the horizontal line is going to be intersecting this graph. So I'm going to solve this as a pair of simultaneous equation. So equation number 1 is equal to equation number 2. K is equal to 12 minus 3x divided by x squared plus 4x minus 5. Cross multiplying, we have a kx squared plus 4kx minus 5k. This is equal to 12 minus 3x. I'm going to bring everything over to the left hand side. So I have a kx squared plus, we have a 4k and plus 3 of x. Then minus 5k minus 12. This is equal to 0. Like what I was saying, I am hoping that the horizontal line that I've created now will cut the graph. Okay, I'm hoping the horizontal line will cut the graph, which means that as I try to solve this as a pair of simultaneous equation, I should be getting an answer for it. What is this kind of equation here? This is a quadratic equation. And when a quadratic equation has solution, because the horizontal line is supposed to be intersecting this graph, that means I am going to be letting the discriminant of this, since it's quadratic, we can make use of discriminant to discuss about its roots. It has roots, so the discriminant, I'm going to let it be bigger or equal to 0. So it is going to be b squared minus 4ac minus 5k minus 12. This is supposed to be bigger or equal to 0. So expanding this, I have a 16k squared plus 24k, then plus 9 minus 4k times this, it will be plus 20k squared. And this is going to be plus 48k. This is bigger or equal to 0. if I were to simplify this, 16k squared plus 20k squared, this gives us a 36k squared. Then plus this and this gives us a 72k, then plus 9. This is going to be bigger or equal to 0. I'm going to divide throughout by 36. This gives me a k squared plus 2k plus 1/4. This is bigger or equal to than 0. Sadly, if I were to factorize this using my calculator, I'm going to get all the decimals, which I think it is actually pretty okay, but I'm going to continue to factorize this by using completing square. So I have this plus 1 square minus 1 square plus 1/4. This is bigger or equal to 0. This leaves me with this square minus 3/4. This is bigger or equal to 0, which I can also rewrite this as k plus 1 square minus square root of 3/2 square. This is bigger or equal to 0, which will give me a k plus 1 minus square root of 3/2. Then k plus 1 plus square root of 3/2. This is bigger or equal to 0. So from here, we can solve for k. I can draw the number line again with respect to k. I will have a minus 1 minus square root of 3/2 and minus 1 plus square root of 3/2. If I were to sub numbers into the entire expression, a number that is bigger than this, I'm going to get a positive. And the same thing for here, negative, positive. I'm looking for the values that are bigger or equal to 0. That means k is going to be less than or equal to minus 1 minus square root of 3/2, or k is going to be bigger or equal to minus 1 plus square root of 3/2. So this will help me to know that, okay, as long as the line, which is y is equal to k, as long as k is less than this number, or as long as k is bigger than this number, I will be able to cause the horizontal line to cut the graph, which means that it is going to produce for me a possible y coordinate on the graph, and the y coordinate on the graph represents the range of the function. Therefore, for part 1, I know what is the range of the function f, since y is equal to k. So I know for the range of the function f, it is going to be from minus infinity to minus 1 minus square root of 3/2, or from minus 1 plus square root of 3/2 all the way until infinity. Okay, replacing k here by y, because k is equal to y. And d over here is the discriminant of the quadratic equation. If I were to let this be strictly bigger than 0, that means you'll be cutting this way when I will have two solutions to the quadratic equation. But if I were to go for equal to 0, that will also include the points where the graph cuts. I mean, the horizontal line y is equal to k, cut the graph at only one point. That is why I went for a bigger or equal to 0, because for this, I plan for the horizontal line to cut the graph, of y is equal to fx. So for it to cut, it can cut at 2 points or it can cut at 1 point. That is why the discriminant is bigger or equal to 0. You know, part 2 is very interesting. It was more interesting than what I thought if you were to actually sketch this graph. I think many times for us, we tend to be a little bit lazy when we are trying to do question as a practice. For example, part 2, we tend to just casually, probably we just look at the solution because it's just sketching, right? But if you look at this question, it is a 4 marks question. Why? Of course, I don't think, okay, I shouldn't say so much now. So let's see why this graph is actually not that easy to sketch, unless we have a proper habit of approaching curve sketching question in our exam. And the habit that I was telling you guys last week, and I've been telling my class also, that if you're to be sketching the graph, please don't assume that please don't just simply assume that your graphing calculator is going to give you all the necessary things that you need to get the full marks. Number one, if you have to look at what that is given to you in your graph calculator, right, the calculator will definitely not give you the asymptotes. So the first thing that I can do to score marks is definitely to sketch in all the asymptotes. So let's do that first. for a graph of y is equal to fx, which is 12 minus 3x over x squared plus 4x minus 5. What is this? Just now in the first question, inequality, we were talking about when to do long division, when to not do long division. So for an expression that is like this is an improper, this is a proper fraction. So since this is a proper fraction, we do not need to do a long division. And when x tends to plus or minus infinity, this entire thing becomes 0. So immediately from a proper expression, we already know that there's going to be a horizontal asymptote y is equal to 0, because horizontal asymptote is defined as the behavior of y when x tends to plus or minus infinity. So when x tends to plus or minus infinity, y becomes 0. So it is going to be the horizontal asymptote. We are going to try to factorize the denominator to get the vertical asymptote. So factorizing the denominator, we have this and x minus 1. So I have two vertical asymptote, x is equal to minus 5 and x is equal to 1. So let me sketch the asymptotes first. And if you were to look at a question that is like this, I will suggest, because we are going to be having minus 5 and we are going to be having a 1. So let's make sure. Remember just now somebody was asking, about the relative positions of the points that are on the graph. So minus 5, I will try to make sure that it is like further away from the y-axis as compared to 1 from the y-axis. So for my graph, y, and this is x. Minus 5, I'm going to draw it, let's say here. So this is x is equal to minus 5. As for x is equal to 1, which is the vertical asymptote, I'm going to draw it closer to the y-axis. If I were to draw one like here, okay, like here, it's just very weird. Where I mean, for me, I will be so tempted, even if I cannot mark it wrong, even if I cannot officially mark it wrong, if I were to be the Cambridge examiner, right, I will be so tempted to give it a wrong in my heart. So I will have a bad impression of this student. Okay, so let's make sure that, although it is not necessary for us to make it like exact, but the relative positions should still give us a good feel of the numbers. So we have this is x is equal to 1. This part of the graph, I think it is okay. So I'm going to sketch it here, making sure that my graph tends towards the asymptotes. So I have this. So my graph tends towards the asymptote. Oh no, okay. And I guess this is okay too. So I'm going to sketch a curve here, a part of the part of the curve here with a maximum point. So here I'm going to sketch the graph with a maximum point, and the graph should tend towards the asymptotes, something that is like this. I can see that the maximum point is here, and of course I'm going to just plug it into my calculator, and I'm going to leave this for a while. I'm going to be writing down the coordinates. Okay, it is here that I do think that some students are going to make some mistakes. You know why? Because for this portion that is here, I do think that it is so easy for us to assume that this part of the graph looks like this. Especially when we know that y is equal to 0 is a horizontal asymptote. But for those of you who are actually plotting this graph together with me, and if you can start to zoom a little bit into your graph, you will start to realize that, hey, this graph seems to be going below the horizontal line y is equal to 0. So it seems to suggest that this part here, right, is going below. And the thing is, this question actually planted a hint. And if you can just be sensitive to the way, if you can just be a little bit more sensitive to this question, it is actually possible to capture the hint. Where is the hint to tell you that this graph should go below the x-axis instead of hovering above the x-axis? It is from here, the range of the function. This number here, just now we have found the range, right? This number here is, if I were to press it into my calculator, this number here is minus 1.87. And this number here is negative 0.134. So reading from this graph, which is supposed to be the graph of y is equal to fx, should have a range that is this and this, or I mean it's going to be in this region or in this region. So for this region here, it actually synchronized to this part of the graph, the y coordinate that is on this graph. So in fact, if you were to press your calculator for the maximum point here, you're going to get the y coordinate as negative 1.87. So the y coordinate here is supposed to be minus 1.20, negative 1.87. Or I think it will be even better if I can indicate this according to what I found in the previous part. So I'll probably indicate it as like that, 1.20 and minus 1 minus square root of 3 over 2. Okay, I'll probably do this. And as for this, if you have had drawn it, if you have had sketched this like this, it is sorry, this should be a dotted line. So if you have had sketched this portion like this, that means the range shouldn't be less than this or bigger than this number. It should be bigger than 0. So obviously, some parts of the graph will be going below the x-axis, and that triggers us to try to analyze the graph a little bit more. So if you were to analyze this part a little bit more, maybe do some zooming in, or you try to you try to calculate, you try to trace your cursor along the graph, you will start to see the y coordinates around this area become negative, and the graph should look like this. Okay, this part I should correct it. So it should tend towards the asymptote, and this part of the graph should be something that is like this. It should still go back to 0, but you go down to a point that is here, and this point that is here will have a coordinate of, from my calculator, 9.20 and minus 0.134, which synchronized to this number here. So the range is supposed to be from minus infinity all the way until negative 1.87, or from negative 0.134 all the way until infinity. Labeling wise, I think this is fine, but for me, I think I'm going to make use of what I found on my calculator from the previous part. So 1 plus negative 1 plus square root of 3 over 2. And I still need to indicate this point and this point from my calculator. This point here, or from just simple calculation, this point here is 40, and this point here is going to be 0 and minus 2.4. This will be my graph of y is equal to fx. Okay. Somebody was asking, does this work? And I assume that whoever is asking this is asking about part 1. Does this work if it is quadratic, or does it work for anything else? Discriminant is specifically meant for quadratic. Okay, discriminant is specifically meant for quadratic because where do we get our b squared minus 4ac? We get our b squared minus 4ac when we have ax squared plus bx plus c is equal to 0. So x is going to be minus b plus or minus square root of b squared minus 4ac. So this is where we analyze our discriminant. If the discriminant b squared minus 4ac is bigger than 0, x is going to have two possible values for a quadratic. X is going to have two values, minus b plus a value divided by 2a, minus b minus a value divided by 2a. If b squared minus 4ac is equal to 0, then x is going to have just one value, minus b over 2a. If this is less than 0, then we are going to have a complex root. But that is our discussion on b squared minus 4ac, specifically traced back to a quadratic equation. Next, let me take a look at part 3. I seriously want to try to do at least part 7, or else I don't think I will have time to finish up the paper during the next session, because the next few questions, right, are actually pretty difficult. So let me very quickly finish up part 3 of this, and let me do one last question, question number 7, then we stop for the night. Let me remove this graph first. Part 3. Part 3 requires a little bit of trial and error. Part 3 describe a pair of transformation that transform the graph from C, which is this graph, so 12 minus 3x over x squared plus 4x minus 5, whoops, let me remove this question first. Wow, I'm happy that you find my graph like really nice. And yes, I'm using a tablet way to write. But it's actually not very easy to use a tablet to write. In fact, when Singapore went to a lockdown during the circuit breaker period, I mean, I don't really use tablet, to write for digital whiteboard and stuff. But we changed our tuition class to online format, and during that period, before my first class, I actually spent a few hours to just practice with my with my tablet, to just write. I just keep writing and writing and writing. I think I wrote for almost an entire day, so that at least when I don't think the way that I'm writing here is the same as the way that I wrote on the actual whiteboard. I think on the actual whiteboard I will write better, I will draw better, but at least it is still readable, and I really spend a lot of time, trying to make sure that as long as I write, at least it is possible for people to see. So oh goodness, I've erased the thing that I've just written for part 3. So part 3, we are supposed to change this, right? I was saying y is equal to 12 minus 3x over x squared plus 4x minus 5. We are supposed to do 2 transformations to go from this to this. Like what I was telling you, I do think that we need a little bit of trial and error. So I'm going to, it is not like I'm going to show you my solution, but during the exam, if you were to try one and you fail, please, your aim is to try to hop from one possibility to another possibility within the shortest possible time, and not to immediately get the correct answer for a question that is like this. As long as you are willing to try a few different possibilities, you can still get the full 2 marks. So the first thing that I have tried is to try to at least get this 3 away so that I can get the minus x. So I'm going to multiply this whole thing by 1/3. So I'm multiplying this by 1/3, this divided by x squared plus 4x minus 5. So this is going to be equal to 4 minus x divided by x squared plus 4x minus 5. And I'm going to try to get this 9. To get this 9, I am going to replace x by, let's say, x minus 5. Because if I were to replace x by x minus 5, I will have my minus x plus 5 plus 4. It will give me a 9. So the uncertainty is in the denominator. Let's see whether it is going to work. If it doesn't work, then we should try some other transformation with proper consideration. So I have a minus 5 square plus 4x minus 5 minus 5. So this is going to be, the numerator is going to be 9 minus x. This is fine. The denominator, hopefully it is going to become x squared minus 6x. If I were to expand this, I'll have a x squared minus 10x plus 25 plus 4x minus 20 and minus 5. So I have a 9 minus x divided by, we have an x squared minus 10x plus 4x minus 6x, 25 minus 20 minus 5. I have an x squared minus 6x. So I've gone through 2 transformations. We have gone through a pair of transformation, multiplying this entire thing by 1/3. It is going to be a scaling by a factor of 1/3 parallel to the y-axis. So this. Then the second transformation is to be replacing all the x by x minus 5. That means it is going to be a translation of 5 units in the positive x direction. Okay. Let me push for one last question so that during the next session we will at least be able to finish it. I can promise you the next session is going to be quite difficult. Okay, somebody has asked whether we are going to be saving the live session. We are trying to work out we are trying to see how it is possible to do this because the file size is actually huge. You know, like the Real Valley paper that we did last week, right? One video that we had, you know, I tried to do a bit of recording for a slightly better recording quality. It actually took up about around 4 GB, so it's huge. So if I were to be saving all, then there will be a little bit of problem. I can understand about this this brain explosion, and I think that is the kick, you know, that we sometimes can get from H2 math, because it requires us to break off from whatever that we've done in our secondary school and to jump to another level. So in order for us to be exposed to enough challenge for us to make that leap, you know, we definitely need to push our brain a little bit more, right? Yeah, reducing the quality is a consideration, so we are thinking about it also. So we'll see how it goes. Let me finish up the last question. Question number 7. Let's see, question number 7. Question number 7 is a Maclaurin's question. Right? Yeah, question number 7 is a Maclaurin's question. and I think this is where the last easy question is going to be. Question 8 is starting to get a little bit more taxing, then after that it's just going to cause the explosion to be worse. But it's a good practice. Okay, we should definitely try to embrace this kind of challenging question in our H2 math, so that, you know, like what I've told the class, I mean in my tuition class before, if you plan to do a if you plan to do a high jump, you will never try to jump at the place where the bar is placed. You must always be able to jump above the bar, so that during the actual competition you can clear it, right? So so we are trying to do that as much as possible. Okay, so question number 7. Question number 7, we are supposed to show this. So we have let's do this one last question together. So I have a sine inverse y, this is equal to ln of 1 plus x. Differentiating the left hand side, I have a 1 over square root of 1 minus y squared. Then dy dx. This is equal to 1 over 1 plus x times 1, chain rule. So cross multiplying, I will have a 1 plus x. Then dy dx. This is equal to square root of 1 minus y squared. Okay, so I've shown. Next, part 1. In part 1, we are supposed to come up with our Maclaurin's expansion, and we are supposed to come up with our Maclaurin's expansion through the processes of differentiation. We are going to make use of our formula sheet MF26, where we have a formula for Maclaurin's. Fx is going to be equal to f0 plus x times of f prime 0 plus x squared over 2 factorial of f prime prime 0, and all the way. Where it is the aim of Maclaurin's is to re-express a function into an infinite polynomial, and what we are supposed to do is not about this x. What we are supposed to do is f0, f prime 0, and f prime prime 0. To work out part of the coefficients, substitute them back into the formula for us to get the expanded version, the polynomial version of the function that is given. So we are supposed to do that in part 1. And we are supposed to expand all the way up to the x square term, which means that we need all the way until f prime prime 0. So we already have dy dx here. What we need is d square y dx square. So let me take this and I'll differentiate. So differentiating this, I have a 1 plus x, then d square y over dx square, plus differentiating 1 plus x, I will have 1, then dy dx. It is going to be equal to differentiating this. Differentiating this, I will be getting a half of 1 minus y squared to the power of minus half, then minus 2y, then dy dx. Implicit differentiation. So this gives me a 1 plus x d square y dx square plus dy dx. This is going to be equal to minus 2, and 2 can be cancelled, minus y over square root of 1 minus y square of dy dx. Okay, we have this, and we are going to try to find f0, f prime 0, f prime prime 0. For f0, that is when x is equal to 0, we are supposed to find y. Y from here, y is going to be equal to sine of ln of 1 plus x. So this is going to be equal to sine of ln of 1 plus 0. So we have a ln 1 is 0, sine 0 is 0. So this is equal to 0. This represents for us f0. Next, we want to find f prime 0, and that is dy dx when x is equal to 0. So dy dx, this is going to be square root of 1 minus 0 square, because y is equal to 0 when x is equal to 0. So 1 square root of 1 over 0 square divided by 1 plus x, which is 0. So I have this. So dy dx is equal to 1. And this gives me my f prime 0. Then we will find d square y dx square when x is equal to 0. d square y dx square when x is equal to 0 will give me f prime prime 0. So this is going to be equal to this, which is minus y over blah blah blah, and y happen to be equal to 0, so this will become 0, then minus dy dx, which is 1, and divided by 1 plus x, which is 0. So this is equal to minus 1. So from here we have our Maclaurin's expanded version for y. Y is going to be equal to f0, which is 0, plus x times of f prime 0, which is 1, then plus x square over 2 factorial of f prime prime 0, which is this. So this is equal to x minus half x squared, and so on. Let me write it down here. So this y, which is a representation of sine of ln of 1 plus x, this is going to be equal to x minus half x squared, and so on. Okay, this is part 1. Again, I do feel that it is pretty simple so far. But for me, my brain will not explode yet. And I do think that for the second half of this paper, for a lot of us, if we are really pushing to complete the second half of this paper, for a lot of us, our brain will probably be half exploded, and this is the kind of healthy explosion that we should try to experience. I'm going to finish up this question, but I do encourage you guys to try to give the second half of this paper a try before our next session, so that at least we can try to do it together at the same time when you have already tried to process some of the parts of the question. Okay, so part 2, we are supposed to make use of part 1, and we try to integrate this. So from part 1, we have this sine ln 1 plus x is equal to this. So now if I were to integrate this, sine of ln 1 plus x divided by x dx. We are supposed to do an approximation, so this will be approximated to integration of this, which I'm going to make use of part 1. So x minus half x squared divided by x dx. And this is going to be integration of x divided by x is 1, minus this divided by this is going to be half x dx. So it is going to be x minus half, and I have x squared over 2 and plus c. So this is x minus 1/4 x squared plus c. This is part 2, and I guess part 3 is pretty simple. Not part 3. The last part is pretty simple. We are supposed to approximate from 0 to 0.5 of sine of ln 1 plus x this divided by x dx is going to be, since we have already integrated this, without the plus c, this is going to be x minus 1/4 x squared from 0 to 0.5. And if you were to substitute numbers in, we have a 0.5 minus 1/4, 0.5 square. Minus away, substituting 0 in, it is going to be 0. Pressing this into our calculator, this is equal to 0.4375. Okay, this is our question number 7. Let's just try this paper, okay? Let's try from question number 8. So this is a series and sequences question, and we are given A1, A2, or A3 all the way to A64, such that AN plus 1 is, let me just blow this up a little bit. So we know AN plus 1 is equal to AN plus D. We are supposed to use the information that is given, and we want to find the value for A1, and we want to find a value for D. We are given two pieces of information. We are given that the sum of all the terms in the first row is equal to 58. So the sum of all the terms in the first row, that will be A1 plus A2, the first row, A1 plus A2 plus A3 all the way until A8. This, according to the question, is 58. And in order for me to sum this, we need to refer back to the information that is given. We are told that AN plus 1 is equal to AN plus D. So for this piece of information here, we can actually rewrite it as AN plus 1 minus AN. This is equal to D. This is the one that gives me a hint of what this series is. This series is an arithmetic progression. It is an AP, because I know in general, one term minus away the previous term, it is going to give me a constant D. So this is going to be an AP with the first term as A1, and the common difference is D. So I'm going to be applying the sum of AP formula. There are 8 terms altogether, so we have a 8 over 2 of 2 times of the first term A1 plus 8 minus 1, 7 times D. So this is equal to 58. We can simplify this. Simplifying this will give me a 4A1 plus 14D. This is equal to 29. So this will form for me my first equation. I think this is okay. Next, we want to look at the third column. The third column, which means that we are looking at this. We will be looking at the third column. So we are going to try to sum all the terms in the third column. There are 8 terms altogether. And if I were to count A8, then A9, A10. So the next term is going to be A11. So then we will continue all the way until A16. Then it will be A17, A18. Then this will be A19, and so on. All the way until the very last term. The very last term will be A59. And according to what the question says, the sum of all the terms in the third column, which is going to be A3 plus, which is going to be equal to A3 plus A11 plus A19 all the way until A59. And according to the question, this is equal to 376. Okay, this is equal to 376. And we need to find a way to sum this. And if you to look at what that is given to us by the question, can you see that from one term to another term, it is going to be plus 8D, because from A3 to A4, it is going to be plus D, plus D, plus D, plus D, plus D. If you were to just keep adding all the D's, you realize that from A3 to A11, it is going to be plus 8D. From A11 all the way until A19, it is also going to be plus 8D. It is going to continue all the way until the last term. So what I see here is another AP. Another AP with the first term as A3. And the common difference is going to be 8D. As for A3 is going to be the third term of the first arithmetic progression. So this is going to be A1 plus n minus 1 times D. So this is going to give me A3. So I'm going to try to work on this as a new arithmetic progression with the first term as this. So the number of terms is going to be 8 terms. 1, 2, 3, 4, 5, 6, 7, 8. So it is going to be 8 terms. 8 divided by 2. Then 2 times of the first term of this AP. This AP is going to be A1 plus 3 minus 1, so 2 times D. This is going to be the first term plus 8 minus 1 times the new common difference. The new common difference is 8D. So we have this. This is equal to 376. So we have this is equal to 376. If I were to divide by 4 on both sides, we will have this as 2A1 plus 4D. Then this is going to be plus 7 times 8. So we have 60D. And this is going to be equal to 94. We can reduce this even further. I'll have A1 plus 30D. This is equal to 47. This will form for me my second equation. I have two equations in terms of A1 and D. I can just press into my calculator to solve for A1 and D. So from my graphing calculator, from my GC, my A1, from my graphing calculator, this is going to be equal to 2. And for D, from the calculator, it is going to be equal to 3/2. Okay. Wow, there are so many questions. Okay, I'm glad that you guys are actually answering each other. Okay. Okay, I'm going to continue, okay? So I have 8A done. Next, let's take a look at 8B. I'm assuming you are the Damien that I know, right? Okay, anyway, let me continue with 8B. So for 8B, the question is telling me that I'm going to be now working on a GP. A GP with the first term as A, and the common ratio is R. We know that the sum to infinity of this GP is 2. So as infinity that is given to me, this is 2. If I were to apply the formula for sum to infinity, I know A over 1 minus R. This is equal to 2. So this is going to form for me my new equation number 1. I'm doing this part B of question number 8. And the question tells me that the sum of the 6 terms from this series from the 4th term all the way until the 9th term is equal to negative 63/256. So from the 4th term, let me call it U4, okay? So U4 plus U5 plus U6 all the way until the 9th term. So U9. This, according to the question, is minus 63/256. So what we are looking at now are terms that were extracted from the original geometric progression, which means that this U4 is also going to be AR to the power of 4 minus 1, AR to the power of 3, then this will be AR to the power of 5 minus 1, then this will be AR to the power of 5 all the way until AR to the power of 8. This is equal to negative 63/256. And what I'm looking at here is another geometric progression. Another geometric progression with this as the first term of my geometric progression. And from one term to another term, it is going to be multiplied by R. So R is going to remain as the common ratio. So applying the sum of a geometric progression, sum of a GP formula, it is going to be the first term AR to the power of 3. This is the first term of my new geometric progression. then 1 minus r to the power of the number of terms according to the question, we know there are going to be 6 terms. So it is 1 minus r to the power of 6 divided by 1 minus r. And according to the question, this is equal to negative 63 over 256. Let me try to reorganize this a tiny little bit. I'm going to rewrite this as a over 1 minus r multiplied by r to the power 3, 1 minus r to the power 6. This is equal to negative 63 over 256. And this will form for me my equation number 2. And the reason why I am rewriting it in this form is because a over 1 minus r is simply equal to 2. So if I were to just substitute 1 into 2, if I were to substitute equation number 1 into equation number 2, then I'm going to replace this entire thing by 2. So I have a 2 r to the power of 3, 1 minus r to the power of 6. This is equal to negative 63 over 256. And now we have an equation in terms of r. We should be able to solve for the values of r. So let's continue to solve for this. If I were to expand this, we will have a 2r to the power of 3 minus 2r to the power of 6 plus 3. This is to the power of 9. This is minus 63 over 256. I will cross multiply this to the other side. That will give me a 512 r to the power 3 minus 512 r to the power of 9. This is minus 63. I'm going to bring this all across to the other side. So I should be able to get a 512 r to the power of 9 minus 512 r to the power of 3 minus 63 is equal to 0. And this is what the question wants me to show. So shown. Okay. So this one is done, and I want to try to find 2 possible values of r. So I guess to find 2 possible values of r for this, I'm going to just press into my graphing calculator. If I were to press this into the graphing calculator, let me show you guys what I've gotten. This is question number 8. So if I were to press this into my graphing calculator, I would press this into my calculator all the way until r to the power of 9. And my answer is going to look something that is like this. Okay, you can see, right? So I have this. If I were to press this into my calculator, this is the answer that I've gotten. I will definitely not use all the complex numbers. So these are complex numbers. This is also going to be a complex number. I'll not be using this. I'll not be using this. I will not be using this. X9, I don't think, I mean, it is not shown here. I got to press my calculator a bit more, but I don't think X9 I will be using. So we will be only the relevant real numbers answers is going to satisfy what this question is trying to say. So which means that R can be either negative 0.977 or R can be equal to this, which is 1.02, or R can be equal to negative 0.5. Of these 3 possible values, I am going to be rejecting this. Why are we rejecting this value? Because according to what the question says, we are trying to deal with we are trying to be dealing with a GP where the sum to infinity exists. So if the sum to infinity of this GP exists, I know I'm going to be dealing with a GP where the modulus of R has to be less than 1 so that the sum to infinity exists. That's why this is going to be rejected. Our answers will be either this or this. Okay. Okay, yes, like what I was saying in the last few rounds, I really want to encourage you guys to use your graphing calculator as much as possible, because that is one of the criteria that A-level has set so that we will be getting marks to be able to make use of our graphing calculator as much as possible. So whenever you have a chance to use calculator, please make sure that you use your calculator. It is actually a good strategy. Okay. Let me take a look at the question. Use some of the first items. Okay. Claire, it is actually possible to use the sum of the first 9 terms minus the first, what Claire is talking about here. What Claire is talking about here is instead of us doing this, we take as 9 minus away as 3. But personally, I do think that this version here is a little bit simpler to solve, because if I were to just simply apply sum of a GP again to this new GP, we are getting something that is really easy for us to simplify. Of course, this in the end, you probably will be able to simplify to what the question asks, but I do think that if I can just work on a single summation of a GP, it is usually going to be easier. To me, I don't think this is necessary, because in the end, we will just be pressing it into our calculator. So it doesn't really matter whether you want to let y be equal to r to the power of 3 or not, because the aim of this question is so that we can make use of the calculator as much as possible. Okay, let's continue. Let us take a look at question number 9. Okay, this is question number 8. So let's take a look at question number 9. Question number 9 is a complex numbers question. Let's read this question together. One of the roots of this complex number is w, where a is real. So we are dealing with a polynomial. We are dealing with a polynomial with real coefficient, which means that if w is going to be a complex number, if w is a complex number and it is a root of this polynomial, that means this tells me that w conjugate, since the coefficient of these polynomials are all real, that means w conjugate will also be a root. It is given to us that this w is in the form of this. It is very important for us to recognize that b is real, because if b is real, that means w, which is given to me in this form, is in the Cartesian form. If the question didn't mention that b is real, I was just talking to my tuition class about this, it can be very dangerous if we were to see this as a Cartesian form, because the Cartesian form will still require us to re-express and regroup it as the real plus I imaginary. So this is important information for us to recognize. So anyway, I know w is going to be in the Cartesian form, and I want to find a and subsequently find w over w conjugate. Let's try to find a first. What are our options? Should we try to make use of factor theorem? Because if I were to make use of factor theorem, then I will try to substitute w into this expression here, because it is going to satisfy, since w is a root of this equation. But before I do that, let's gauge. If I were to substitute w into this expression, I must have the possibility to more efficiently being able to expand it all the way to the power of 3, because if that is possible, then substitution will be a good idea. If not, I will probably try to make use of w conjugate. I will probably try to make use of the fact that w conjugate is also a root. I will form 2 factors and then multiply them together to get the quadratic factor and see whether I can do a bit of comparison to find a. But I do think that for a case that is like this, it is pretty simple for us to expand b minus square root of 2i to the power of 3. So let me do that for now. So if I were to let fz be equal to this z to the power of 3 minus a z minus 66, and since w is a root, that means fw should give me a 0 by using the factor theorem. So w is equal to this. So this from here, I know w to the power of 3 minus aw minus 66. This is equal to 0. So what we have is a b minus square root of 2i to the power of 3 minus a times of w, which is b minus square root of 3i, then minus 66. This is equal to 0. It should be easy enough for us to expand this, but we should be a little bit careful. Let me try to be careful myself too. I'm going to expand this. This is going to be b to the power of 3 plus 3 times of b square. then minus square root of 2i, then plus 3 times of b, then minus square root of 2i square, then plus minus square root of 2i to the power of 3. Then expanding this, I have a minus ab, then this times this, plus square root of 3ai, and minus 66. This is equal to 0. Oops, I've really made a mistake. I realized this is square root of 2. So this is minus square root of 2i. So this is going to affect this. So here I should have a plus this times this plus square root of 2ai. Okay, so this is what I have. Then if I were to expand this, this is b to the power of 3. Plus this is going to be minus. So minus this times this minus 3 square root of 2 b square I. Then this times this, negative square root of 2 square is going to be positive square root of 2, so I will have a plus 6. I square is going to be negative 1, so I have a minus 6b. Then this minus 1 to the power of 3 is negative 1 square root of 2 to the power of 3 is 2 square root of 3. I to the power of 3 is negative I square, so I have a positive 2 square root of 2i, and minus ab plus square root of 2ai minus 66. This is equal to 0. I have an intention of doing this. My aim is to try to regroup everything into the real plus I imaginary. Then I can compare the left and right hand side to form two equations in terms of a and b, and it will probably help me to subsequently solve for a and solve for b. And a is what I want. So I'm going to regroup. Let's regroup and put all the non-i's together. So we have a b to the power of 3, and then this minus 6b, and minus ab, then minus 66. This I'm going to group it as one term. Then those terms with an I, it will be this. So minus 3 square root of 2b square. Then this, it is plus 2 square root of 2. And we have this. So plus square root of 2a. And this is equal to 0. And we can see 0 as 0 plus 0i. So I can match this to this and this to this. So we have a b to the power of 3 minus 6b minus ab minus 66. This is equal to 0. And we have the other one, which is this, to be equal to this. So minus 3 square root of 2b square plus 2 square root of 2 plus square root of 2a. This is equal to 0. We can divide by square root of 2 throughout. So we have a minus 3b square plus 2 plus a. This is equal to 0. And I guess I'm going to try to make a the subject. A is going to be equal to 3b square minus 2. I'm going to substitute this back into here so that I can form an equation in terms of b. And I can probably then try to solve for b and then subsequently for a. So I'm going to substitute this into this. So that will be b to the power of 3 minus 6b minus a. A is 3b square minus 2. Then times b minus 66. This is equal to 0. So we have b to the power of 3 minus 3b square, 3b cubed. Let me just write it down. So b to the power of 3 minus 6b. Then minus this is going to be minus 3b cubed. Then this I have a plus 2b, then minus 66. This is equal to 0. So we have we're going to have a minus 2b to the power of 3 minus this minus 4b minus 66 is equal to 0. We can just simplify this a tiny little bit more. So this is this plus 2b plus 33. This is equal to 0. Then I'm going to just press it into the calculator. If you press this into the calculator, you're going to get the value of b to be equal to minus 3. Just one single value. So now b is equal to minus 3. We can finally find a. So therefore a is going to be equal to 3 times b square. So minus b square minus 2. So it will be 27 minus 2. A is equal to 25. So okay. So this a here I have found. Okay, this is equal to this a here. This is equal to 25. Okay. Okay, anyway, I'm just going to write it here. So a A here is equal to 25, and I have found B also, right? Yes, I found B to be equal to -3. This is the same feedback that I remember I got from some of my VJC students last year, because the expansion is very tedious. In fact, I tried this question by making use of the fact that W conjugate is a root. I try to form the quadratic equation, find the quadratic factor. It is not going to be that much easier also, because the comparison itself also require you to do a lot of expansion. So I don't think we can actually escape from this expansion. And as for, so we just got to try to do it more carefully, okay? And if you think about it, actually VJC has been pretty fair, isn't it? Because the first few questions had been pretty simple. So it will leave, and as long as you don't take the first few questions for granted, try to do it at a good pace, which I think on Tuesday I did remind you guys. If you realize that the questions are easy, please don't slack, okay? If you realize the questions are easy, just see whether you can quicken up a little bit, get those easy questions off, whatever that you're trying to do first. Then hopefully you are going to leave yourself more time to spend in the next few questions, because you will never know when a difficult question or a tedious question that is like this is going to come out. As for how I expand b minus square root of 2 to the power of 3, this is number one, binomial expansion. So you can either use binomial expansion, but for me, I am actually making use of standard results, because a plus b square we know is a standard result. So I've actually also memorized a plus b to the power of 3 as a standard result, or else just apply binomial expansion. Okay, this is just binomial expansion. You can make use of the formula that is on your MF26 to expand this. So you'll get a 3 choose 1 in replacement of this 3, and you'll get a 3 choose 2 in replacement of this 3, and so on. I mean, if you just imagine, I didn't actually go and calculate, but if you just imagine from the first few questions, if it is easy enough, out of the 52, let's say we get a 40, which means that for the next few questions, we just need to get a 20, 30, we should be able to hit a B or an A already. Wow, thanks. Yeah, I feel a bit embarrassed. You know why? Because I've never actually, I mean, all my friends did, but I've never actually read or watched Harry Potter before. So but I'm glad, okay, I'm glad I get a praise from you. Okay. Let me see. Okay, I'm going to continue, okay? I can understand why you are laughing about using your GC, because you must really try, okay? Using the GC to try to solve for this, it is about pressing apps, and then after that use the polynomial simultaneous equation solver to solve. Please, if you are taking A-level this year, please learn how to use your graphing calculator. It is not very difficult, as long as you are willing to use it like every single time when you do math. It is very easy for us to pick it up. Part two is, to me, I find that part two is sort of like interesting. Let's take a look at part two. Oh wait, I I realized I did try to watch Harry Potter's. Yeah, I did try to watch. I did try to watch Harry Potter, and I watched the movie. Okay, never mind. Okay, I don't want to say any more, okay, because I already feel embarrassed because I don't really know much about Harry Potter. So I don't know why I always like to add an S to Harry Potter's, because I think I'm always imagining them as a group. So Harry Potter, okay, it is the name of that guy. So I'm so sorry, Harry Potter fans. I'm okay, never mind. I'm just gonna focus on complex number. Now we are supposed to look at this A. We are supposed to look at this A W square plus 66W. And we are given that W is RE to the power of I theta, we're given some information for r, I'm given some information for theta. But if you were to try to do this, let me show you what I mean. Okay, if you were to try to substitute re to the power of I theta into here, you will probably get stuck, because this is going to be re to the power of I theta, then square, plus 66, then w, which is re to the power of I theta. So you will be getting something that is like ar square e to the power of I2 theta plus 66 re to the power of I theta. So you will be getting something that is like this. You will be stuck, because from here, if you want to try to find the modulus of this and the argument of this, is the first thing that you need to do is to at least compress this into one single re to the power of I theta or x plus iy first, which is very difficult. So it is not that it is totally wrong to substitute this inside. It's just that by substituting this in, you're not getting it correct yet. So is there any other options that I may try so that I can avoid doing something that is like this? Yes, there is. Because according to this question, there's another piece of information that, and I'm going to try to make use of that piece of information, which is the fact that this part 2 originates from this statement that is here. And in this statement, it says that w is a root of this. W is a root of this, which means that in part 2, if you have had tried this, it is fine. But what I need you to do is to recognize that if this strategy is getting a little bit more difficult, think about whether there's another option, which is what I'm working with my class this week. You know, what if we can just press on a little bit to think and see whether there's another option, because very likely in our H2 math, if one good strategy, this is an okay strategy, okay, this one here is an okay strategy because at least it is not wrong. If a strategy that is not wrong is not working, very likely there's going to be another possible option. You just need to read the question again or think about it a bit more. You should be able to find the other option. For example, like what I was telling you, this w is a root of this, which means that we know w to the power of 3 minus aw minus 66. This should be equal to 0 by factor theorem that we discussed just now. And if you were to look at this, isn't this very, very similar to what we are looking at here? A, then 66, 66. Which means that if I can just re-express this as aw, then plus 66, this is going to be equal to w to the power of 4. And since what this question is asking for is aw square, then plus 66w, w to the power of 3. So 66w, that means I will just need to multiply this whole thing by w. So I will have this plus 66 is going to be equal to w minus multiplied by w to the power of 3. So it will get me a aw square plus 66w. So this, according to what that is given to us by the question, is also w to the power of 4. And do we know what is w? Yes, we know. W is re to the power of I theta. So we have re to the power of I theta, this to the power of 4. In the Euler form, we just need to apply multiplication and indices. So we have r to the power of 4. This is e to the power of I 4 theta. And now we have gotten the modulus, and we have now gotten the argument, which means that looking at this form that we have here, we do know what is the modulus of aw square plus 66w. This is this that is here, so r to the power of 4. This, done. Then how about the argument? The argument of aw square plus 66w. This is going to be the argument, so this is 4 theta. And here is where the trick lies. I mean, this is another trick that we need to be able to try overcome during the exam, which is the fact that 4 theta, if theta is between minus pi and minus 3 pi over 4, if theta is between this and this 4 theta, so if I were to multiply this throughout by 4, it is going to be between minus 4 pi and minus 3 pi. And when we try to write argument, we should try to write that argument. We should try to write all argument of complex numbers to be between minus pi and pi. So we want to produce our answer to be of an argument that is between this and this, and 4 theta is just not between minus pi and pi. In fact, it is too small, so I'm going to plus 2 pi to this. If I were to plus 2 pi to this, I'll get a minus 2 pi. Then here is going to be minus pi. It is still insufficient. I need to get it into something that is between minus pi and pi. So I'm going to plus another 2 pi. So plus another 2 pi, I have 4 pi. Then this is going to become 0. And this is going to become pi. And now it is okay. That is why my answer is not going to be left as 4 theta. My answer is going to be left as 4 theta plus 4 pi. Extremely tricky. And that is because the question tells us that theta is between minus pi to minus 3 pi over 4. And knowing that in our complex number in Singapore, at least, we are trying to go for any argument when I produce it as my solution to be expressed to be between minus pi and pi. Okay, this is question number 9, part 2. You know, for this, okay, for this, I do feel that I mean, for the questions and the comments that I'm seeing now, right, I do believe that all of you who are looking at this can actually get this if you are willing to try to switch your direction. For example, like what I was telling you, if you were to be just focusing on part 2, well, this is what I was telling the class. Even like just now today, I had 2 JC2 classes, so we were trying to work on questions that are like this. And if you are very hyper focused on just WRE to the power of I theta, substituting it back into here, and you realize that somehow it doesn't work, instead of just pushing for that direction a little bit more, try to step back and ask yourself, is there some other hints or clues that you have not considered? Because if we have just considered this and then looking at this expression, I mean, definitely you will just substitute this in. But if you were to just step back, you will realize that, hey, there's one more piece of information that is not used. And this piece of information is actually giving you a very, very obvious hint by having an A and having a 66. As long as you are willing to make use of this entire piece of information, substitute this W in to get this expression, then hopefully you will realize how similar this portion is to what the question is asking. Then there will be a higher chance for you to continue this way. Okay, so anyway, let's take a look at question number 10. And I hope that you can continue to tell yourself, okay, if you are doing something that is somewhat okay but you don't get it correct, like for example substituting W as RE to the power of I theta immediately, think about another option. If there were to be another one, you should try both instead of just trying to bash through this same direction here. Let's take a look at question number 10. I remember it is a vectors question. Is it a vectors question? Yes, it is a vectors question. This vectors question is actually a pretty okay question. Oh, okay. I realize I have missed one question indeed. Okay, W divided by W conjugate. I think we should go through this. Let me go back and go through this question, okay? So question number 9. Question number 9. Okay, let's very quickly go through this W over W conjugate. So we have already found what is W. Just now we say that W is equal to minus 3 minus square root of 2i. Okay, let me finish up this last part over here. So if we are talking about W over W conjugate, this is going to be equal to minus 3 minus square root of 2i divided by W conjugate, which is minus 3 plus square root of 2i. So it is just a simple rationalization. So we will multiply the numerator by minus 3 minus square root of 2i divided by minus 3 minus square root of 2i. For the numerator, it is just simply minus 3 minus square root of 2i square. For the denominator, it is going to be minus 3 square plus square root of 2 square. So for the numerator, it is going to be 3 square, it is going to be 9, minus 6 square root of 2i. Then this square is going to be equal to minus 2. And this is going to be divided by 9 plus 2, this is 11. So we have a 7 minus 6 square root of 2i divided by 11, or we can also express this as 7 over 11 minus 6 square root of 2 over 11i. Okay, yeah, this is easy. Wow, you guys can really ask a lot of question. I'm glad, okay, that that you're asking me so many questions, but at the same time I want to try to answer as many questions as possible, but I think it's not very feasible. So I'm so sorry, okay, just in case I didn't manage to answer your question. Let me move on first, okay? Let me move on to question number 10, vectors. So in question number 10, we are given M with a position vector relative to O as this. So this question tells me that OM, this is equal to 6 minus 5, 11. Okay, I have OM as this. And L1 has this equation. We are going to be changing this to the vector form. Okay, I don't think this is very useful. So we'll be changing this in a while. As for pi will be in the dot, the more useful form will be the dot product form. So let's change this. 4 minus 2 minus 1. This is equal to 30. I want to part 1 show that L1 lies in pi. So let's try to convert this into a vector form first. So for part 1, I'm going to try to just change this. It is going to be useful for what I'm going to be doing later anyway. So for part 1, okay, I have x is minus 7, blah blah blah. So what I'm going to do is I'm going to let this entire thing be, let's say, lambda. So I will let x minus 7 be equal to lambda. My aim is to make x the subject. So x is going to be equal to 7 plus lambda. And I'm going to let y over 3 be equal to lambda. This tells me that y is equal to 3 lambda. And I'm going to go for the z plus 2 over minus 2. I'll also let this be equal to lambda. So z here is equal to minus 2 lambda. The reason why I am doing this is because I'm going to try to express x, y, z in the position vector form. And this tells me that I have a 7 plus lambda, I have a 3 lambda, and minus 2 lambda. So the equation of the line L1, this will be R is equal to, if I were to break this up into 7, 0, minus 2, and then the other part is going to be 1, 3, minus 2. Okay, so this is my L1. It is going to be useful. Let me just write down L1 here. So L1 is going to be R is equal to 7, 0, minus 2, then plus lambda of 1, 3, minus 2. Okay, we are supposed to show that L1 lies on the plane pi. So for a line to be lying on the plane pi, so in order for L1 to be lying on the plane pi, I'm going to make use of two geometries to show this. Number one is I'm going to show that a point that is on L1 is also going to be a point that is on pi. And I'm going to show that L1 is going to be parallel to pi. With these two geometries being satisfied, I will be able to show that L1 lies on pi. Let me repeat again. I'm going to show that a point that is on L1 lies on pi, and L1 is perpendicular to pi. L1 is parallel to pi. So these two, first, I need a point that is on L1, and I think a convenient point is when I let lambda be equal to 0, then I'll get a position vector of a point 7, 0, minus 2. I want to try to prove that 7, 0, minus 2 is a point that is also going to be on the plane pi, because I already know it is going to be on L1. So let's prove this. 7, 0, minus 2. I'm going to sub it into the left hand side of the plane pi. So this dot 4 minus 2 minus 1. This dot 4 minus 2 minus 1, I'm going to be getting a 28, then plus 0, then plus 2. This is equal to 30. It is equal to the right hand side. Therefore, I know the point 7, 0 minus 2. This point lies on L1 and lies on pi. This will form for me my first piece of information. Next, I want to check to verify that L1 is parallel to pi. So if L1 is parallel to pi, I just simply need to check that L1 is going to be perpendicular to the normal vector of pi. The normal vector of pi is 4 minus 2 minus 1. So let's do that check. I'm going to take the direction that L1 is parallel to, is 1, 3, minus 2. So I'm going to take this and I will dot the normal vector to the plane. The normal vector to the plane 4 minus 2 minus 1. This is equal to 4 minus 6, then plus 2. This is equal to 0. Therefore, I know L1 is parallel to pi. This is going to form for me my second statement. So statement A and statement B, both of this tells me that L1 lies on the plane pi. Okay, so this is part 1. Then we want to find the Cartesian equation of the plane that contains L1 and M. Okay, this is also simple. Let's try this. The Cartesian equation of the plane. The Cartesian equation of a plane that contains L1. So let's say this is L1 and contains the point M, where the position vector of M is 6 minus 5, 11. So what I'm going to do is, since from the line L1, we already know a direction that it is going to be parallel to. This direction is 1, 3, minus 2. And from the line L1, we have a point that is convenient enough for us to quote. There are a lot of other points that I can quote. I just need to let lambda be, any values. I'll be able to get another point. I'm going to go for lambda to be 0. So this point has a coordinate of 7, 0, minus 2. I'm going to name this point, let's say I name this point A. Then this MM is 6 minus 5, 11. So in order for me to form the Cartesian equation, let's try to first work out the normal to this plane, this new plane. So for the normal, I already have one direction that is parallel to the plane, 1, 3, minus 2. This is parallel to L1, and since L1 lies on this plane, so this 1, 3, minus 2 will also be lying on the plane. Another vector that is going to be parallel to the plane will be the vector AM. So I'm going to find AM. I'll take OM, 6 minus 5, 11, and I'll minus it to this. Well, minus 7, 0, minus 2. So this will give me a minus 1, minus 5, and a 13. Okay, so I have this. So to get the normal vector, I'm going to take AM, minus 1, minus 5, 13, and I will cross the direction that is parallel to the line L1, which will also be parallel to the plane that I'm trying to find. So 1, 3, minus 2. And this, it will be 10 minus 39. This is going to be minus 29. Then it will be 13 minus 2, so this is going to be 11. Then I will have a minus 3 plus 5, so this is going to give me a 2. So this is going to be the normal to the plane. And since the plane passes through this point, I'm going to make use of either of the point to form the dot product version of the equation of this plane. Oops, I shouldn't call it pi. Let's just call it a plane. So I have so this plane will be r dot minus 29, 11, 2. This is equal to, maybe I'll just take the point A. Its position vector is 7, 0, minus 2. So this dot minus 29, 11, and 2. And this will give me a minus 203, then minus 4. It gives me a minus 207. The question wants me for the Cartesian equation. So I'm going to replace r by x, y, z. So I have a x, y, z dot minus 29, 11, 2. This is minus 207. So the Cartesian equation of this plane will be minus 29x plus 11y plus 2z. This is minus 207. Okay. Yes, Damien, you can just simply substitute the entirety of equation, the entirety of L1 into plane pi. If you can prove that, add the entire, this whole, when I substitute the entire L1, substitute the entire this into the plane pi, for example, according to what Damien has mentioned here, right, he is suggesting this strategy. That means what Damien has suggested is to substitute this entire line, which is going to be this 7 plus lambda, then 3 lambda, this entire line, then minus 2 lambda, into the plane pi. So on the left hand side of this plane pi, he is talking about part 1 of this question, 4 minus 2 minus 1. But if you can just continue with this, you will actually be getting a 30. So once you have proven this, you can immediately say that L1 lies on the plane pi. And why is it that we can do something that is like this? Let's not forget about this R. What is this R representing? This R is not representing the plane. This R is representing the position vector of a point that is on the plane. Where this R is representing the position vector of a point that is on a plane. If I have the line L, which is R is equal to A plus lambda B. With this R here, a lot of people, some people, okay, they just misunderstood that this R represents the line, but it is really not. This R represents the position vector of a variable point that lies on the line L. And if a coordinate is going to be written in the form of a vector, then this coordinate is going to be of the form x, y, z, and it is a position vector, so it must start from the origin. So R is a notation that is used to represent this position vector of a variable point that lies on the line L, and the geometry of the line L is one where we have already defined it to be passing through a point A, and it is going to be parallel to the vector B. So if I were to see this as a vector, so my aim is to try to describe R. How can I describe R so that R will represent the position vector of so many multiple points that are on this line L? We can just do a simple vectors addition. Just from O, we will just try to add this vector A, and I'm going to try to add this vector. And for this vector, I don't know how this vector is going to be. I don't know what this vector is, but I do know that this vector is going to be parallel to B. So if this vector is parallel to B, I can go for a scalar multiple of B. So R here is equal to A plus this vector A plus this vector lambda B. So if R represents the position vector of any point that is on the line, and I just sub this vector into the plane's equation, I just sub this entire R into the plane's equation. Let's not forget what is this, okay? This here is R. So if I were to sub R of the line L1, and R represents every single point that is on the line L1, I sub this into the plane, and if it's satisfied, it just simply tells me that every single point that is lying on L1 lies on the plane pi. If this can actually work out to be a 30. So if every single point that is on the line L1 lies on the plane pi, then L1 lies on the plane pi. Okay, so this is also a very good strategy. So Damien, please go ahead and do that, okay? Let's continue. Next, we have already found the Cartesian, so this is also done. Okay, so next, the point N is the foot of the perpendicular from M to the line L1, and the line L2 is going to be passing through M, and it's going to be passing through N also. And we want to find the position vector of N. Okay, this is pretty okay. So we have a point M, and N is the foot of perpendicular from M to the line L1. So this, and this point here is N, and we are talking about this being 90 degrees. For L1, it is going to be equal to this, and since the point N is the point that is lying on L1, which means that this R that we have just talked about can represent the position vector of N, position vector. So we are talking about this starting from the origin. So R of the line L1 can also represent the position vector of ON. So I'm going to go for ON to be of the form of this. So ON is going to be equal to 7 plus lambda, and then 3 lambda, and minus 2 lambda. Okay, ON can replace this R because R represents the position vector of any point that is on L1. And but with this piece of information, I will only know that N is a point that is lying on L1, but it is not any point that is on L1. It is the point that is specifically one that represents the foot of the perpendicular. So as a foot of the perpendicular, we know that MN is going to be perpendicular to the line L1. So let's find MN first. MN will be ON minus OM, and that will be 7 plus lambda, 3 lambda, and minus 2 lambda. So it is this minus ON. ON is OM is 6 minus 5 and 11. So this we will have 1 plus lambda, and this is going to be 5 plus 3 lambda, and we have minus 13 minus 2 lambda. Okay, MN is this, and we know MN is perpendicular to the line L1. And from the equation of the line L1, we know that L1 is going to be parallel to the vector 1, 3, minus 2, which means that MN will also be perpendicular to this vector. So I'm going to take MN, and I will dot this 1, 3, minus 2. This should give me a 0. So it will be 1 plus lambda, 5 plus 3 lambda, minus 13 minus 2 lambda. This dot 1, 3 minus 2 is equal to 0. So we have a 1 plus lambda plus 15 plus 9 lambda. Then this will be plus 26 plus 4 lambda. This is equal to 0. And we will have a 14 lambda. 14 lambda plus this will be 42. This is equal to 0. This tells me that lambda is equal to negative 42 divided by 14, negative 3. So with this negative 3, we can now find the actual position vector of N, which is going to be the position. Okay, so this is what we are supposed to find. So I'm going to substitute this back into here. So we have a 7 minus lambda, 7 minus 3, 7 minus 3, then 3 times of minus 3, then minus 2 times of minus 3. This gives me ON as 4 minus 9, 4. So let me record it down here. So I know ON is 4 minus 9, 4. Okay, next, we are supposed to find the area of the triangle OMN. Okay, a pretty standard question, I would say. So we are going to find the area of triangle OMN. The area of triangle OMN. So O M N. M, I know it has a coordinates of 6 minus 5, 11, and we have just found this is 4 minus 9, 4. So the area of this triangle is going to be half of modulus of I'm going to take OM cross ON. So this is going to be half of OM, which is 6 minus 5, 11. This cross 4 minus 9, 4. So this will be half of this cross this. I will be getting a 79 and 20 and a minus 34. So this will be half of square root of 79 square plus 20 square plus negative 34 square. I'm going to just write it as 34 square. This is equal to 44.2 units square. Yeah, I agree. Okay, the last two questions are ridiculously long. So next. Next, we want to find the acute angle between L2 and pi. L2 is a line that passes through M and N. Okay, L2 is actually I see this question and I think you interpreted it wrongly. The question didn't say that L2 is perpendicular to the line that passes through M and N. Okay, so I believe this is a wrong interpretation of the question. So L2 is going to pass through M and N, and we are supposed to find the acute angle that is between L2 and the plane pi. So I'm going to be writing some stuff here, okay, but let me just do a quick diagram of the scenario. So we have a L2 and we have the plane pi. The plane pi is R dot 4 minus 2 minus 1. This is equal to 30. It is given to me by the question already. And L2 is going to pass through the points M and N. So I don't know where is M and N, but I know L2 is going to possess a direction that is going to be parallel to M and N also, since L2 passes through point M, since L2 passes through the point N. So in order for me to find the angle that is between L2 and pi, I'm going to be making use of this. But my problem is I don't have a vector that is lying on the plane pi. This vector is very inefficient if you were to try to find it, because it has to be a, how am I going to describe it? It's going to be a direct shadow of L2 being cast on pi, in order for me to get this vector, which I don't have since plane pi is a surface. So I'm going to do an improvisation. Instead of finding this angle theta, I'm going to try to find the angle alpha instead. And this angle alpha is the angle that is between the normal vector to the plane pi and L2. So this is the normal vector. So I'm going to try to find alpha. And with alpha, I should be able to find theta. So this is 4 minus 2 minus 1. So let me first find a vector that is parallel to L2. And that will be vector MN. So for vector MN, it is going to be ON minus OM. So we have a 6 minus 5, 11. Then minus away ON, which is 4 minus 9, 4. So this is equal to 2 and 4 and oh no, this is 7. Okay, so I have a 2, 4, 7. So 2, 4, 7 is going to be parallel. 2, 4, 7 is going to be parallel to L2. So I'm going to take this vector here as vector 2, 4, 7. Let's try to find alpha. So to find alpha, I'm going to make use of the dot product. I will take 4 minus 2 minus 1 dot 2, 4, 7. this. Using dot product, it is going to be modulus of 4 minus 2 minus 1, modulus of 2, 4, 7, then cosine alpha. Okay, and what I'm going to try to do is to work on alpha as an acute angle, because the question did also mention that they want the acute angle that is between L2 and pi. So what I'm going to do is I'm going to do an improvisation to the dot product equation by adding an extra modulus to force this alpha into an acute angle. So cosine alpha, this is going to be this dot this is going to be equal to 8, then this, then this. This is going to be equal to minus 7, then modulus divided by this. This is going to be square root of, this is going to be square root of 21. Then this is going to be square root of 69. This tells me that alpha is going to be cosine inverse of 7 over square root of 21 square root of 69. This is equal to 79.403 degrees. So I know what is theta. Theta is just going to be equal to 90 degrees minus alpha, 79.403 degrees. This is equal to 10.6 degrees. Oh, did I actually find MN previously? If I found MN previously, we should just try to use, we can definitely try to use the MN that I found previously. So anyway, let's continue with the last two questions. The last two questions are like indeed way longer, and it is scary, okay? When we are doing a paper that is like this, most likely we'll be doing from question number 1, and then suddenly you realize the last two questions are like so tedious. And especially a question that is like 11, it's scary because the way the question try to phrase and describe to us a scenario already require a bit of time to process in order for us to continue and do whatever the question is trying to ask us to do. Let's try to process this question together. So according to what this question says now, we are supposed to be making a pencil with 2 different colors, and for this pencil, it is going to be obtained, the shape of this pencil is going to be obtained by rotating a trapezium. Okay, let me just do a sketch, a rough sketch based on what the question says first, and then we try to make refinement along the way. Okay, so this trapezium PQRS, so let's say it is something that is like this. It is going to be revolved about the x-axis. So let's say this is P, let's say this is Q, let's say this is R, let's say this is S. So when this is revolved about the x-axis, we'll be getting something that is like this, and then a cylinder, then another cone. Okay, that is why we are getting this pencil with two ends, with 2 colors. So I guess that is the creativity behind this question. So I have this. Okay, so we are supposed to work on V, which is the volume, and this volume is supposed to be the largest possible. It is given to me that PQRS lies on a curve, and this curve is of a form that is like this, where A and B are positive numbers. So I can see that this curve that we are talking about is an ellipse. So let me draw an ellipse. So let's say I have something that is like this and this. So for this ellipse, I know that the horizontal radius is A and the vertical radius is B. So this point here is minus A0. This point here is going to be A0. Here we will have a 0 minus B, and this should be a 0B. Okay, so this is an ellipse, and the question tells us that R and S are minus A and 0. So this point here is going to be R. This point here is supposed to be S, which means that my initial diagram is wrong. So R and S, it should be here, which means that my diagram should be something that is like this instead. Right, R and S is supposed to be this way, And the question actually told me one more piece of information. It tells me that PQ is parallel to the x-axis. So R and S is here. And when we try to code, we should try to code, according to the order of the, according to the order that the shape is being named to us. So we will code either anti-clockwise or clockwise. This is the convention that is in our syllabus. So if this point is S, if this point is R, I guess this point is going to be P, Q, R, then S. Okay, so I'm guessing that my diagram is like this, and this is a line that is going to be parallel to the x-axis. So now I sort of like know what is my diagram already. This is incorrect. My diagram, let me draw a slightly better one. So my diagram that can probably help me to look at the scenario. Oops, this is ugly. Let me just try to draw it again. Okay, so we have an ellipse, so it is going to be something that is like this. This point here is going to be point R, so this is minus A and 0. This point is point S, this is A and 0. And if I were to draw a line that is going to be parallel to the x-axis, this point will be P and this point is going to be Q. So this shape, this parallelogram here, is going to be rotated about the x-axis. So this is what that's going to happen. So at least, I'm interpreting the question, and this is going to be the graph that I'm getting. So let's make use of this. Let me shift this here. Oh no, where's my graph? Okay, let me try it one more time. Okay, so I have this, and we want to verify that P, which is A cosine theta, B sine theta, is going to be lying on this curve. And then I want to write down the coordinates of Q. We are given that this theta over here is between 0 to pi over 2. So to verify that P lies on this curve, I guess it is simple enough. We just need to try to substitute the x and y coordinates into the left hand side, and let's check whether it is going to be 1. So at the point P, I know the x coordinate is equal to A cosine theta. I know the y coordinate is equal to B sine theta. I'm going to substitute this into the left hand side of the equation. So if I were to go for x squared over A squared plus y squared over B squared, this is going to be equal to A squared cosine squared theta, this square divided by A squared plus y squared, which is B squared sine squared theta divided by B squared. So this can be cancelled, this can be cancelled. We'll be left with a cosine squared theta plus sine squared theta, and this is equal to 1. Therefore, I know P lies on the curve x squared over A squared plus y squared over B squared. This is equal to 1. And it further justify that the diagram that we have just sketched together, it is correct because we have sketched P in the first quadrant, and if A and B are positive numbers, and then theta is between 0 to pi over 2, which means that cosine theta is going to be a positive number, sine theta is going to be a positive number, this will be a positive number, this will be a positive number, so P should be lying in the first quadrant. And if PQ is supposed to be parallel to the x-axis, and we are looking at them lying in this curve, and this curve is an ellipse which is symmetrical to y, then this should help me to immediately code the coordinates of Q, because they should be a reflection of each other about the y-axis. So Q should share the same x coordinate, should share the same y coordinate as P, but the x coordinates are going to be negative of each other. So if P is A cosine theta, the x coordinate of Q should be minus A cosine theta, and they will share the same y coordinate. The y coordinate is B sine theta, so this is also going to be B sine theta. Okay, so let me write down the coordinates of Q here, which is what we have just found. This is minus A cosine theta and B sine theta. Let's continue with part 2 of this question. So for part 2 of the question, we are supposed to show that the volume is equal to this expression here. Okay, we are supposed to show that the volume is this. We are supposed to show that the volume V is this expression over here. And what I'm going to do is I'm going to try to break this up into 3 parts. So it will be the cone, then plus the cylinder, then plus another cone. And in fact, this cone is going to be exactly the same as this cone because they are going to be symmetrical about the y-axis. So I'm going to alter a little bit. So I'm going to make use of the cylinder plus 2 times of the cone. So for the cylinder, we know what is the radius of the cylinder. The radius of the cylinder is just going to be the y coordinate of P. So the radius is going to be B sine theta. And the height of the cylinder is going to go from here to here. So if this distance here is A cosine theta, this will be 2 times of A cosine theta. As for the cone, the radius is going to be the same as this. So the radius of the cone is going to be B sine theta, and the height of the cone is going to be from here all the way until here. Here the x coordinate is A, here the x coordinate is A cosine theta. So this length here, which is this, is going to be A minus A cosine theta. So let's see whether we can prove this. The volume of the cylinder, pi r squared B sine theta squared h, which is 2A cosine theta. Then plus 2 times of the volume of the cone, which is 1/3, pi r squared. R is B sine theta squared times height. Height is A minus A cosine theta. So we have this as a we have a 2A then B squared pi of sine squared theta cosine theta. Then plus here we have a 2/3 of this is A times B squared, so AB squared of pi of sine squared theta for this, and for this is going to be minus 2/3 of AB squared of pi sine squared theta cosine theta. This and this are the same, so I have a 2 minus 2/3, that will be 6/3 minus 2/3, that will give me a 4/3. 4/3 AB squared of pi sine squared theta cosine theta plus 2/3 of AB squared pi of sine squared theta. And we are supposed to prove this. So I guess what we can try to do is I'm going to factorize out as much as possible so I can have 1 here. And this 1, I suppose, if I can just factorize out this entire expression here, I'll be able to get 1. So I'm going to factorize out 2/3 AB squared pi of sine squared theta, which gives me a sine squared theta here. And that will leave me with a 2 cosine theta. And plus this is 1. So I've gotten this, and this, if I were to compare to what I have here, that means K is going to be equal to 2/3 AB squared. Okay, 2/3 AB squared. Okay, we have gotten this. This A here is 2. Let me write it in red color so it's easier for me to see also. So this A here is 2/3. Sorry, this K here is 2 over 3 AB squared. Hermione, I am just assuming A is bigger than B because usually a pencil is like longish in shape. So I am assuming A is bigger than B, but A may not necessarily be bigger than B, but that will give me a very weird pencil. So I am just assuming based on my experience. Okay, so we don't really know whether A is bigger than B, okay? Actually, it is not very possible that they will give me an angle that is obtuse. Furthermore, if it is really obtuse, then it has to be another shape. It has to be another question already. So I don't think it is necessary for us to worry about whether the angle is acute or obtuse. For this kind of information, we should just follow what the question has said. Okay. Next. Part 3. Part 3, we are supposed to look at the value of theta when V is a maximum. We want to find the value of theta when V is a maximum. So, and I want to prove that theta, which is this theta, oh, what's happening? I want to prove that theta, which is this theta 1, is going to satisfy this equation over here. So, if I have V, let me rewrite. If I have V as 2 over 3 AB square of pi sine square theta and 2 cosine theta plus 1. If I have V as this, so I guess in order for me to continue from here, we need to do a dV d theta. So 2 over 3 AB square pi is a constant. I'm going to just write this and I'm going to do a product rule for this. Sine square theta, I'm going to hold it constant. I'm going to differentiate this. This will give me a minus 2 sine theta. Then plus, plus this is going to be equal to, hang on, let me take a look at this. So this is going to be, if I were to then differentiate this, this will give me a 2 sine theta and cosine theta, and I will have a 2 cosine theta plus 1. Okay, we are doing a product rule. And this is equal to 2 over 3 AB square pi. We are supposed to let this be equal to 0 and try to show that it's satisfied. Try to show that it becomes this. Let me try to simplify this a little bit more. So what we have now is going to be a minus 2 sine cube theta and plus 2 sine theta cosine square theta plus 4. So plus 4. Then plus 2 sine theta cosine theta. And I guess I am going to factorize out sine theta. So AB square pi. I'm going to factorize out 2 sine theta. That will then leave me with a minus sine square theta plus 2 cosine square theta, then plus cos theta. Okay, I will have this, and this will give me a 4 over 3 AB square pi of sine theta. This, since we are going to be showing this expression over here, and I'm going to be letting this whole thing be equal to 0, when I let this whole thing be equal to 0, then it will be sine theta is equal to 0, or this entire expression to be equal to 0. So I think I'm going to try to work on this expression, and I want to see whether I can try to re-express this as an expression that is in terms of just cosine. So let me just try to make a change to this first. So this is going to be negative of 1 minus cosine square theta plus 2 cosine square theta, then plus cosine theta. So this will be 4 over 3 AB square pi of sine theta, and I will have a minus 1 plus cosine square theta plus 2 cosine square theta plus cosine theta. So this is 4 over 3 AB square pi sine theta. And this plus this is going to give me a 3 cosine square theta. Then I will have a cosine theta minus 1. Nice. It is exactly this expression over here. So when I let my dv d theta, when I let this be equal to 0, that means it is going to be 4 over 3 AB square pi of sine theta and a 3 cosine square theta plus cosine theta minus 1. This is equal to 0. This tells me that sine theta must be equal to 0, or 3 cosine square theta plus cosine theta minus 1 is equal to 0. And this is not applicable because theta is going to be between 0 to pi over 2, so it is impossible for sine theta to be equal to 0, which means that we have gotten this, and hence showing what the question wants us to show. When it is at its maximum, theta should satisfy this. And we are supposed to find the value of this theta, and at the same time we should also continue from here to try to show that it is a maximum. So to continue from here, if I were to solve this based on if I were to try to solve this as a quadratic in terms of cosine theta, I will be getting two values for cosine theta. It will be either negative 0.76759 from my GC, or cosine theta is going to be equal to 0.43425. This I will be rejecting because theta, once again, it is going to be from 0 to pi over 2. It is impossible for cosine of that theta to be negative, so I've gotten this, which means that theta over here is equal to 1.1216. And we need to show that for this value of theta, it is going to cause V to be a maximum. Then we can say that theta 1 is equal to this value. So I need to check. Whether this is going to give me a maximum. And to check that, we are going to find d square v d theta square when theta is equal to 1.1216. And I'm not prepared to do the differentiation one more time. What I can try to do is to just plug this into my calculator. Let me show you what I can get if I were to press this into my calculator. This is question number 11. If I were to press this into my calculator, I'll be getting this. Basically, I just need to press into my calculator math, then you select n derivative. You should get this d dx thing. For me, I press this. Okay, for me, I press this expression into my calculator to differentiate. I get this number, then I multiply it by 4 over 3. So it is like really very fast, and I don't see why this cannot be accepted. In fact, this is a very ridiculously good strategy because I'm showcasing that I can make use of the calculator. So this multiplied by the differentiation of this when theta is equal to 1.1216. I got it from my calculator, negative 3.9008 of AB square pi. And this is less than 0. Therefore, I know V is at its maximum. This implies that theta 1, where theta 1 is the value of theta that is going to cause it to be maximum. So theta 1 is going to be equal to 1.12. Okay, that is what the question wants. Okay, so please remember, okay, we can actually press calculator for this, or else if you were to be differentiating one more time, right? Well, you know, I think it is madness to try to differentiate this once again. So anyway, let's look at the last part. The last part is actually pretty okay. I'm going to quickly finish off this last part. Then we should be able to do the last question and finish it within the next maybe 15 minutes or less. The last part, when theta is equal to pi over 6. When theta is equal to pi over 6, we want to find okay, let me just shift this down a little bit. Okay, when theta is equal to pi over 6, that means point P here, when theta is equal to pi over 6, point P here will be A times of cosine pi over 6, and that is square root of 3 over 2. And then B sine of pi over 6, and that is half. So we have a coordinate of P that is like this. And an eraser is going to be formed out of here instead. And it is going to be formed by taking the arc PS. So this part. The arc PS, and this part is going to be rotated about the x-axis. We are supposed to find the volume of this eraser that is going to be formed. So to find the volume of this eraser, the volume, we are going to be making use of integration. So it's going to be pi integrating from this value to this value. This value is going to be square root of 3 over 2a. So it is from the x coordinate of P all the way until a, the x coordinate of S. Of here it should be y square dx. And we are talking about this part of the graph. So to find this part of the graph in terms of y, I'm going to take the equation of the curve. It is that ellipse. So I'm going to take this. This is x square over a square plus y square over b square. This is equal to 1. So y square over b square, this is 1 minus x square over a square. So y square is going to be equal to b square multiplied by 1 minus x square over a square. So y is supposed to be plus or minus b, square root of 1 minus x square over a square. If I want to be really specific, this part of the arc, it should be y is equal to positive b, square root of 1 minus x square over a square. And then because the below portion is going to be y is equal to negative b, square root of 1 minus x square over a square. But it doesn't really matter here because we are making use of y square, which is this expression. So here, square root of 3 over 2a all the way until a of y square, this will be b square, 1 minus x square over a square dx. B square, I'm going to just take it out of the integration notation. So I have this. And I will be integrating from square root of 3 over 2a all the way until a of 1 minus x square over a square dx. So this is going to be b square pi. Simple integration that we are looking at here, this is x minus x to the power of 3 divided by 3a square from square root of 3 over 2a all the way until a. So we have a b square pi. Substituting this in, it is going to be a minus away a to the power of 3 divided by 3a square. Then minus away, substituting this in, it is going to be square root of 3 over 2a minus square root of 3 over 2a to the power of 3 divided by 3a square. And when we do this, goodness, it is like really very tedious. So it is going to be, we're going to be having a b square pi of this minus this. This is 2 over 3 of a square minus this minus this. This is going to be 3 square root of 3 over 8 a. Oops, this is just a, not a square, a. So I mean, if you want, we can still factorize out a. That will leave me with a b square pi of 2 over 3 minus away 3 square root of 3 over 8. Okay, or you can just leave this in decimal, it is fine. The problem is because of this a here, where it makes it impossible for us to try to press into our calculator from here. Or else we should have just pressed into the calculator. So I guess this substitution is not a choice, it is forced by the way the question is being phrased. Okay, the question did says that a is a positive number. Okay, I remember seeing that somewhere a and b are positive. Where is it? Yeah, it is here. Where the question says that a and b are positive constants. Okay. Anyway, let me do the last question. It is I don't think it is as scary as this question number 11, but it is still somewhat a slightly longer question. So let me just finish this last question, question number 12. And I think 12 is actually more standard as compared to, I mean, it is tedious, but at least it is a standard enough question. So according to the information that is given to us, we are looking at a ball bearing that is dropped from a point O. So let's say this is O. So from this point here, it is being dropped and after a while, the velocity of this is v, and according to the question, x, which is the displacement, it is taken from O. So this is going to be x. We want to find the rate. It is given to us, not we want to find. It is given to us that the rate of change of v is this. So we know dv dt. This is equal to 10 minus 0.001 v squared. And I want to show that it is this. So what this question requires us to do is to solve, this differential equation. So I'm going to solve this as a variable separable. So I'm going to bring this over to the dv dt side. So 1 over, I'm doing part 1. So it is 1 over 10 minus 0.001 v squared and dv dt. This is equal to 1. So integrating both the left and right hand side with respect to t, it will be 1 over 10 minus 0.001 v squared dv. This is equal to integration of 1 dt. So in order for me to integrate this, I think what I'm going to do is I'm going to factorize out 0.001 from the denominator so that I can have a 1 as the coefficient of v squared. And the reason why I'm doing so is because I want to make use of our MF26, our formula sheet, to integrate this. So this integration of dt, 1 over this is 1000. I'm going to shift it over to the other side. So it'll be 1 over 1000 integration dt. As for this, I'm going to rewrite it as 1 over, here is 100 squared minus v squared dv is equal to this. So on the left hand side, when I integrate this, it is going to be using the formula sheet, it is going to be 1 over 2 times of 100. Then ln modulus of this will be 100 plus v divided by 100 minus v. This is equal to 1 over 1000 of t plus an arbitrary constant. I'm going to go for a. We are supposed to make v the subject. So I'm going to multiply this across to the other side. So we have a ln of 100 plus v divided by 100 minus v is equal to, multiplying this across to the other side, we will have this as a t over 5. So it will be 200 divided by this, so t over 5 plus this is going to give me a 200a. So it will be modulus of 100 plus v over 100 minus v. This is e to the power of t over 5 plus 200a, which I'm going to rewrite this as e to the power of 200a, e to the power of t over 5. So 100 plus v over 100 plus b over 100 minus v. This is going to be plus or minus e to the power of 200a e to the power of t over 5, which I'm going to rewrite this again as just simply b e to the power of t over 5, where b here is this plus or minus e to the power of 200a. And we better solve for b, because according to what this question has asked us to show, there is no b or whatever constant, everything is given to us. So we are going to make use of the fact that the ball is going to be dropping at O, and when it is dropped, its speed is 0. Okay, I'm going to make use of this. Its speed is 0 when it is first dropped. So by making use of that piece of information, I know that when t is equal to 0, v is equal to 0. Substituting it into here, it is going to be 100 plus 0 divided by 100 minus 0 is equal to be to the power of 0. This tells me that b is equal to 1. So if b is equal to 1, let me just continue here, okay? So if b is equal to 1, if I were to continue here, that means I know 100 plus v over 100 minus v. This is going to be equal to 1 time of e to the power of t over 5. And we are supposed to make v the subject. So let me cross multiply. We have a 100 plus v is equal to 100 e to the power of t over 5. Then minus ve to the power of t over 5. Let me group all the v's together. So I'm going to bring this over to the left hand side. I will have a ve to the power of t over 5 plus v. This is equal to 100 e to the power of t over 5 minus 100. So ve to the power of t over 5 plus 1. This will be 100 e to the power of t over 5 minus 1. So v here is going to be 100. Then e to the power of t over 5 minus 1 divided by e to the power of t over 5 plus 1. Okay, so this is what the question wants me to show, part 1. It is really very tedious. I'm wondering how you guys are taking it so far, because we do need some stamina to do this. Now we are breaking up into 2 parts, 1.5 hours, 1.5 hours. But I'm just wondering whether it is possible for us to just do 3+ hours. I mean, now I'm already overshooting the 1.5 hours. So I'm just wondering whether it is possible for us to do 3 hours, that the entire paper together. But I'm not sure, okay, whether you guys are going to have the stamina to last through the entire 3 hours together with me. But anyway, that's a consideration. Let me just do part 2 first. Part 2, we want to find the value of v0, and this is the value when t gets very, very large. So when t gets very large, that is like when t tends to infinity. So when t tends to infinity, v, which is this 100 e to the power of t over 5 minus 1 divided by e to the power of t over 5 plus 1. Yeah, it's not as easy to consider an expression that is like this when t goes to infinity. So I guess one thing that we can try to do, there are a few different options, but one thing that we can try to do is to do this, like long division. But I'm a little bit lazy, okay? So I'm going to do a long division, but I'm going to do this instead. So plus 1 minus 2 divided by e to the power of t over 5 plus 1. So I'm going to group this as one single expression so that I can rewrite v as 100. And this divided by this is 1 minus 2 over e to the power of t over 5 and plus 1. So when t tends to infinity, the denominator will go to infinity, which means that we have 2 over infinity. This will make v tend to 100 of 1 minus 0. So this is 100. This gives us v0 here. Next, by using chain rule, part 3. By using chain rule, we are supposed to show this v in terms of x. What we have gotten so far is v in terms of t. So if I were to make use of chain rule to equate these 3 terms together, I guess this is a bit like secondary school. So if I were to just use what I've learned in my secondary school, dv dt is equal to dv dx multiplied by dx dt with the rate of change equation. And the question tells me that v is equal to dx dt. So this, which means that I have dv dx. This is supposed to be equal to v. I know where the question is trying to direct me to. The question is trying to direct me to form a differential equation in terms of dv dx, so that I can then try to solve the differential equation to get a v in terms of x, which means that this dv dt shouldn't continue to, I shouldn't continue to work with dv dt with a t. I should try to find a way to re-express dv dt so that it is going to be in terms of either x or in terms of v. And in the first part of the question, we have already been told that dv dt is 10 minus 0.001 v squared. So I'm going to make use of this piece of information to re-express this to 10 minus 0.001 v squared. And like what I was telling you, I know I'm doing this because I know the intention of this question. If I cannot remove all the differential from this, at least I want to get a differential that has v and x only. I want to try to remove t, so that if I can solve this, I will get v in terms of x. Okay, that will, by trying to do this, it will make this possible. So I'm having this, and I'm going to rewrite this, dividing this across to the other side. We have a v over 10 minus 0.001 v squared of dv dx. This is equal to 1. So integrating both the left and the right hand side with respect to x, this will be v over 10 minus 0.001 v squared dv is equal to integration of 1 dx. And I think I'm going to do the same thing. I'm going to factorize out 0.001. This will give me a v over 10,000 minus v squared of dv is equal to integration of 1 dx. This is going to give me a 1,000 divided across is going to be 1 over 1,000 integration of this dx. And to integrate this, we are going to use fx, f prime x. If I were to see the denominator as the fx, then the f prime x will be minus 2v. So I need a minus half in front so that I can get a minus 2v for the numerator here. And as for the denominator, I'm going to just keep it as 10,000 minus v squared dv. So integrating this is f prime x, this is my fx or f prime v, and this is fv. This will be ln of modulus 10,000 minus v squared is equal to minus 2. I'm going to bring it across to the other side. This will give me a minus 1 over 500. Of this is x. Then plus an arbitrary constant. Since we have already used a and b previously, I'm going to use c. This is a motivating expression because we are seeing something that is like this here. So we have a modulus of 10,000 minus v squared. This will be e to the power of this, which I'm going to write it as e to the power of c, e to the power of minus x over 500. So 10,000 minus v squared. This is going to be equal to plus or minus e to the power of c, e to the power of minus x over 5,000. That means we are going to be working on v squared is equal to 10,000 plus d e to the power of minus x over 500, where d here is plus or minus e to the power of c. And I guess I can solve for d, and I'm going to make use of the fact that once again at O, the velocity is equal to 0 and the x is also equal to 0, where there's no, it is dropped when the speed is equal to 0, and when it is dropped, the displacement is 0. I'm going to continue here. So when x is equal to 0, v is also going to be equal to 0, and I'm going to substitute it inside here. So I have a 0 is equal to 10,000 plus de to the power of 0, which is 1. This tells me that d is going to be equal to negative 10,000. So v squared here is going to be equal to 10,000 minus away 10,000, then e to the power of minus x over 500. So v here is going to be equal to the square root of this. I'm going to factorize out 10,000. I know when I square root 10,000, I'm going to get the 100 of 1 minus e to the power of negative x over 500. And I'm going to square root this entire thing. I'm going to go for a positive square root because this ball bearing is dropping downwards, and v is defined as a downward, and according to the question, there's no, it's just going to go down all the way. So v is not going to go back up. So v is going to be positive all the way. So we have this 100 square root of 1 minus e to the power of minus x over 5,000. Okay, I'm choosing the positive square root because v is supposed to be bigger or equal to 0. So this part 3, it is also proven. And the last part, okay, let's just finish off this last part. The last part is easy, but it just requires a lot of substitution. So for this last part, we want to find the distance, so we want to find x when t is equal to 5. And I want to give it to two decimal places. So when t is equal to 5. When t is equal to 5, let's try to find v first. So v is going to be equal to 100 e to the power of 5 over 5 minus 1 divided by e to the power of 5 over 5 plus 1. So if you were to calculate v for this, let me see, v is going to be equal to 46.212. Somehow I'm really getting a little bit excited coming to this last part because I think probably the last few questions are really very long. And like what I was telling my tuition student, I was just thinking, doing a live stream that is like this, will this ever become like a late night math kind of thing? And now it is coming to 11. I guess we are really starting to do this late night math kind of thing. So v is equal to this. I'm going to substitute into here to find x, and that will give me my answer. So v is equal to 46.212, and I'm going to equate this to 100 square root of 1 minus e to the power of negative x over 500. And we are going to solve for this x. So it will be square root of 1 minus e to the power of negative x over 500 is 46.212 divided by 100. So 1 minus e to the power of negative x over 500. This will be 46.212 divided by 100 square. So e to the power of negative x over 500 will be 1 minus 46.212 over 100 square. Then minus x over 500 is equal to ln of 1 minus 46.212 over 100 square. And then x is going to be minus 500 multiplied by ln of 1 minus 46.212 over 100 square. And if you then press this whole chunk into the calculator to 2 decimal places, we have this 120.11, and we are done with this VJC paper.